Hi students, welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you or not, so that we can start with today's day 5 of 9 days challenge. And wait a second. Yes. So everybody do let me know in the chat box. Are you all ready? Are you all ready for the class? And am I visible? Am I audible to all of you or not? Yes, students. Today we'll be doing amines and purification of organic compounds. So there is a chapter, purification of organic compounds, qualitative, quantitative analysis, which I have divided into two parts. First part is purification of organic compounds, a very small topic that we'll be doing today. And in the next class, that is on Wednesday, we'll be doing biomolecules and or quantitative qualitative analysis. Right? Okay, everybody? Yes. Class 11 student, listen to this class. Definitely you can listen to the class, right? Definitely you can definitely listen to the class, right? Okay, yes, students, let us start the session without wasting any further time. Purification of organic compounds, it's a class 11 chapter, right? That is in your syllabus, so we'll be discussing that as well. Amines is a different chapter. This is a part of GOC, right? A very small part of GOC that we'll discuss today. Right, I have not completed that thing on this channel, so that's why I decided to take this in today's session, right? Okay, yes, because amines is also a small chapter only. It's not a very big chapter that you should be getting scared of. So it's a small chapter, it's a good chapter, it's a scoring chapter. And you know what we have seen, that usually students they feel like amines is not that important, let's skip this chapter. And today all the PYQs that I'll be showing you, these are latest PYQs, and you will see that questions are not tough, questions are easy. And the best part about amines is its connection with the other parts of organic chemistry is there, but it is as compared to like how alcohol, phenols, this aldehyde ketones, hydrocarbons, haloalkanes are connected to each other. Amines, you will not see repetition of those many reactions, right? In case of amines, right? Okay, so that's why it's a chances are if they ask you questions from amines, it will be individual amine question. It will not be a mixed question. Though mixed question can be formed in amines as well, right? Okay, so let's start this lecture. And here first thing is structure of amines. So guys, what is exactly amines? Amine is written as RNH2. R, that is the alkyl part. R is the alkyl part. This is nitrogen and this is H2, right? So basically what you have here, you have one nitrogen in the middle. In the middle you have nitrogen here, that I can just write it over here. And if you see in this case, nitrogen, obviously when nitrogen has three bonds, it has a lone pair. So nitrogen, you can see this over here, that it is having nitrogen, one lone pair, one hydrogen, two hydrogen, and third one is alkyl. So how many sigma bonds it has? 1, 2, 3. 3 sigma plus 1 lone pair, it is going to be sp3 hybridization. Because of the number, the total steric number is going to be 4 here. Because of this sp3 hybridization, it exists in a tetrahedral geometry, right? And in tetrahedral geometry, you have situation like this, where this will be the pyramid and here you will have one alkyl, right? And because whenever we talk about the shape, we ignore the lone pair. That is why the shape will be pyramidal. The shape is going to be pyramidal, right? And if you see this from here, any tetrahedral structure, if I talk about, any tetrahedral structure, if I talk about, guys, this is, let's say, first bond, second, third, and wait a minute, two hydrogens, and one lone pair is there. right? One lone pair we have. Let's have this red as the lone pair. So this is the lone pair, this is the alkyl part, these are the two hydrogens. So it has a tetrahedral structure, the geometry is tetrahedral. But if you see the shape of amine, because we don't consider lone pair in the case of shapes, that is why this is a pyramidal shape. As you can see, it is not a planar, it's like a pyramid. Have you seen pyramids, right? It's like this kind of shape, okay? This kind of shape, that is a pyramidal shape, right? And if you talk about, ma'am, how many different types of amines you can have, so let's talk about the classification of amines. So we can have 1 degree, 2 degree, 3 degree and quaternary ammonium salt, right? So four type of amines we can have. First is you will have R, right? Here this is nitrogen, here you have one lone pair, here you have two hydrogens and one R group, right? Then you have nitrogen. Now you have one hydrogen and two alkyl groups, right? And if you have nitrogen, but now you have three alkyl groups. Three alkyl means R dash, R double dash, and R. And last one is that, let's say you don't have the lone pair, right? But instead you have four alkyl groups here. And whenever nitrogen has four, it always has, whenever nitrogen, see, always remember that, because in all this process you will be able to understand the mechanism if you know this basic thing about nitrogen, that nitrogen wants to form three bonds, right? If nitrogen is forming, let's say, two bonds, it will have a negative charge. If nitrogen, let's say, it is forming four bonds, it will have a positive charge here, right? And that is why here it is forming three bonds and here it is four bonds, so that's why it is a positive charge over here, right? And now let's talk about, if you have only one alkyl group, other two are hydrogen, that is primary, right? It is primary amine. And then if you have, let's say, two alkyl groups, that is secondary amine. And if you have three alkyl groups, that is tertiary amine, right? And if you have four alkyl group, that is called as quaternary amine. Quaternary amine. Now guys, understand one thing, that what we are doing here, we are just replacing the hydrogens here, right? Hydrogen is subtracted, alkyl is added. Hydrogen is subtracted, two hydrogens are replaced by two alkyl group, that is secondary. This is in case of ammonia. You have ammonia, three hydrogens, you replace one hydrogen, that is 1 degree. You replace two, it is secondary. You replace three, it is tertiary. You replace three hydrogens, then you add one more alkyl group, that is total four alkyl group, that is quaternary ammonium salt. Now understand one thing, that if you talk about 1 degree, 2 degree and 3 degree alcohol, in case of alcohol, they are not considered as different functional groups. But in case of amines, they are different functional group. This is a different functional group, this is a different functional group, right? So they are under a category of different 1 degree, 2 degree, 3 degree. They have entirely different properties. So that is why they are considered as different functional groups, right? Okay, everybody. Now, the first part is preparation of amines, right? Nitrogen has lone pair, aromatic rings are planar, so why not sp2? Nitrogen has lone pair, aromatic rings. Where is this aromatic? This is not aromatic. Where is this aromatic? Is this a ring, guys? This is not even a ring. So how can you say this is aromatic? In chemical bonding of inorganic chemistry, we have studied that whenever we want to find the hybridization, we'll find out by calculating the sigma and lone pair. Sigma bonds connected to nitrogen is 3, one lone pair, that's why its hybridization is sp3, right? Okay, it's not a planar structure. Right, everybody? Now let's talk about preparation of amines. Super duper important reactions. Each reaction you will see yourself that is repeated in your PYQs. Right, everybody? Yes. Now, they are not functional isomers. I said functional groups. Isomers should have the same or same molecular formula, right? They don't have same formula. The alkyl group is being added here, so they don't have same. They are considered as different functional group only, right? Okay. Yes, understood. uh Okay. Now let's see this thing, reduction of nitro compounds. If you talk about nitro compounds, that is NH2. You have to replace this oxygen with the hydrogen. That means you have to do reduction. Whenever you add hydrogen, you take out oxygen. That is called as reduction. Now some specific reagents are used here for the reduction. First is catalytic hydrogenation in presence of ethanol. So catalytic hydrogenation means simply you add H2 in presence of nickel, palladium, right, platinum, all these things, that simply converts NO2 group to NH2 group. Then if I talk about, this is an important reaction, which is tin plus HCl or iron plus HCl, then this NO2 group is converted to NH2 group, right? Now, a very important part about this particular reaction is that which one is more preferable. This has been asked in your PYQs in the form of assertion reasoning questions. Okay, so some important parts, one important part about this particular reaction is that whether tin usage is better or to use iron, is it better? Which one is better? Let's talk about reduction with scrap. Reduction with Fe scrap and HCl is preferred. Now the question is why? Why iron is preferred? That is the your assertion. Why reduction with iron is preferred? That is the assertion. The reason is because FeCl2 formed gets hydrolyzed to HCl. The FeCl, that is the byproduct of this thing. You have FeCl, hydrogen is attached here, and this FeCl is formed here. Now FeCl2 that is formed here, that is hydrolyzed and gives us acid, and acid is a reagent here. That means you don't have to use HCl externally, right? Now on commercial purposes, whenever the reagent is itself produced in the reaction, that is a very good thing. It's a business minded thing, right? So whenever they don't have to use HCl from outside again and again. HCl is here, what is formed? FeCl2 is the byproduct, right? That is converted to HCl upon hydrolysis, and that HCl is again used here, again give this product, again give this, again used here. So it is a full complete cycle that is going on, and that is the reason FeCl2 is preferred here. Now you got it, why FeCl2 is preferred. That is the reason FeCl2 to release HCl during the reaction. So very less amount of HCl is required to initiate the reaction. Understood? So if they ask you why FeCl is preferred, the reason is because it gives HCl that helps to initiate the reaction, and it is consumed in the reaction itself. So that is why it makes the reaction more commercial, right? Then there is reduction of amides, right? Now what is amide? This is a derivative of carboxylic acid. You have C double bond O, OH, right? When OH is replaced by NH2, that is amide. Now this particular group is called as amide. So write it here. This is called as amide. So whenever we have amide, we are using a reducing agent like LiAlH4, right? Lithium aluminium hydride. Then what is happening? Lithium aluminium hydride is going to convert this double bond O to CH2. That's it. That means, ma'am, how it is different? There is a one more reaction that we will study, that is Hoffmann bromamide degradation. There also amide is getting converted to amine, But in case of, this is the point I am writing here only because students get confused in Hoffmann and this reaction, bromomide degradation. Now in case of, we'll discuss about this with the help of mechanism itself. But remember that in this case, you will have the formation of RNH2. In this case, same number of carbons, same number of carbons. In this case, one less carbon, one less carbon. Okay, that you must know. That in case of LiLH4, you are not reducing the number of carbons here. It's just that this simple thing, this CO is getting converted to CH2. That's it. That is when you have lithium aluminium hydride. Right? Now, let's talk about more about lithium aluminium hydride. This is a very important thing. If you talk about reactant, if you have cyanide, let's say C triple bond N, then if you use lithium aluminium hydride, it is going to convert it to amide, right? That is this thing. If you have amide, right? If you wait a minute, it should be it should not be amide. Wait a minute, let me just write it myself because that's not possible. Wait a minute. It is a reducing agent, so it will convert it into amines. Let's talk about what kind of amines. One by one, we'll talk about this. So if I talk about cyanide, C triple bond N. So what will happen here? Let's say this is R, this is C triple bond N. Here two pi bonds will break and this will be converted to RCH2NH2. That is a primary amine. That is a primary amine. Now let's talk about amide. If you have RC double bond O, NH2. That is converted to, this oxygen is again converted to H2. So it will be again RCH2NH2. Right? Then if I talk about this thing, that is isocyanide. What is an isocyanide? Isocyanide is RNC. NC. Again, two pi bonds will break. You will add H2 here. This is RNH2 and this is CH3. Right? And here it will be converted to, see, this is primary because on nitrogen you have two hydrogens. Tell me, is this primary or secondary? Tell me, from isocyanide, is that primary or secondary what you have here? Is it primary? Yes, that's a typing mistake, right? So now if you see here, to this particular nitrogen, right, you have the connection of only one hydrogen, right? Two alkyl groups are linked here. That means whenever two alkyl groups are there, that is 2 degree amine, right? And what about nitro? If you have RNO2, directly it will be converted to RNH2 and that is primary amine. That is primary amine, right? Okay. Now let's discuss some questions based on this very simple concept. You will see a lot of questions that are there. See, in amines the concepts are less, but a lot of questions you will see here, right? So JEE Mains 2021 question is, the major products of A and B in the following set of reactions are what? Two reactions you have. First is, in this case, LiAlH4 and hydrolysis. And in this case, you have hydrolysis and you have H2SO4. That is a dehydrating agent, right? So here reduction will go on and here dehydration will go on. Firstly, hydrolysis will be there. This is a very interesting one, right? So simply firstly tell me one thing. This is going to cause a reduction, right? Because LiLH4. So it will convert. Reduction of this is not possible. So reduction of this is that it will convert this to CH2NH2, right? So CH2NH2 means what you will have here, you will have CH2NH2. That means this thing is not possible. This thing is definitely not possible. What is A? A they are asking now. OH is as it is, this is CH2NH2. That means either this or this is the correct answer. First two options are neglected here, right? Now we will talk about what will happen here. You have hydrolysis. Whenever you cause hydrolysis, if you remember, I told you in aldehyde ketones, like multiple times I told you there, that whenever you have C triple bond N, right, that is converted to C double bond O NH2, right? On partial hydrolysis, on complete hydrolysis, this will be converted to C double bond OH. So here you can see we have done complete hydrolysis. So for complete hydrolysis, it is converted to, where should I write it, right? So on partial hydrolysis, if you see, right, this is converted to, I am writing here only, right? On partial hydrolysis, this I have told you before also, if you have partial hydrolysis, this is converted to amide. That is this thing. It's a very important thing because the reaction of amide and carboxylic acid are there in your syllabus. If you have complete hydrolysis, that is converted to C double bond OH, right? So that is converted to C double bond OH. So here you will have COOH. Now dehydration will be from, this is OH will be eliminated, this will be alpha, and this will be beta. So here H will be eliminated from here, this will fall here. This you have studied in hydrocarbons, you have studied this, right? It's a very famous reaction. Whenever you have dehydration, right, from the alpha and beta carbon, you have the elimination of water. So from alpha OH and beta H is eliminated. So in the end, this will be eliminated, and here you will have double bond. So it will be carbon here. This is as it is. This is double bond, and this is COOH. So you can see this over here. This is the correct answer here. So answer is third is the correct answer here. Is that clear? Right? Okay. See, it's not like it was a tough question. It's just that 2-3 reagents. You should know that what is the main function of these reagents, right? And that's how you will answer this, right? Now, next question, again 2021 question, right? This is from a different shift, right? In the reaction given below, LiAlH4 and hydrolysis you are doing. Now for this you must know that LiAlH4 is a selective reagent. Who will tell me that LiAlH4, does it reduce double bond as well? Does it reduce double bond as well? Definitely no. Double bond is not reduced here. Double bond will stay intact. This will be converted to CH2, right? For reduction, this will be converted to CH2, right? So what you will have, let me see. Options are NH2CH2, NH2CH2, COH, it will not be there. It is directly converted to, one thing to I forgot. LiAlH4, it is there. But here this is converted, no. One thing. This is not converted to C double bond O on reaction with LiAlH4 is reduced to alcohol. Okay? Is reduced to alcohol. But amide, when you have amide on reaction with LiAlH4, is reduced to CH2NH2. So this will be converted to CH2. This will be converted to COH, right? So 2 carbons, then COH, and this is as it is, I think OH, both are not OH. One is OH, their double bond is also. So answer will be A, right? So if you can see, here this is getting converted to OH, this is getting reduced to CH2, and double bond is intact here. That is the function of LiAlH4 here, right? Okay, everybody? When double bond is present in adjacent to phenyl ring, LH will double bond get converted to single bond. Very good, Sudhir. Very good, very good. Oh, next question is, yeah, next reaction. Let's talk about the next reaction over here, guys. Let's talk about that, what you have here. So if I talk about, you have nitrobenzene, you have Fe steam, iron with steam. Then this NO2 is converted to nitro, so that is N double bond O simple. Okay, that is converted to nitro, so that is N double bond O, right? Now these are some specific reactions, very important. If you have zinc NH4Cl, this is your PYQ. This is a question from your PYQ, okay? Zinc NH4Cl and water, zinc CaCl2 and water. Then this will be converted to hydroxylamine, that is NHOH. That is converted to amine, which has, instead of hydrogen, it has OH. That is hydroxyl part. So it is hydroxylamine. Right, everyone? With Fe steam, it is getting converted to N double bond O. With zinc NH4Cl, it is getting converted to hydroxylamine, that is NHOH. Now let's talk about, if you have a zinc NaOH along with ethanol. Zinc you have in basic medium, and that is ethanol. Now what will happen? Now a coupling reaction will take place. That is not N triple bond, N will not be there. Rather it will be a benzene ring. I'll just draw it here, right? A benzene ring that is there. A benzene ring. Okay? Wait a minute, let me just draw it. You have, let's say, let's draw it like this. Okay? In diazo, what you do, this is N triple bond, but here it is N, this is N, and this is H, this is H. That is formed. Okay? That is hydroazobenzene. Azobenzene is when you have this N triple bond, this is N and this is azobenzene. But when this azobenzene is having hydrogen here, right, instead of pi bonds, that is hydroazobenzene, right? So when you have zinc NaOH ethanol, then hydroazobenzene is formed here, right? Okay. Yes, I'll be covering the important mechanisms. Okay, don't worry about that. Like full on, I'll do today, right? Okay. Yes. Now let's talk about NH4SH is a specific reducing agent, right? That is a specific reducing agent that converts which one? It's a specific reducing agent which reduces only one NO2 to NH2. So if you have this thing, only one of them will be reduced to NH2. Either this or this will be reduced to NH2. So it does not reduce all the NO2 groups to NH2. It is a specific region where only one is converted to NH2 here, right? That is NH4SH. These are some specific reagents that we were talking about as of now. Fe steam, zinc NH4Cl, then zinc NaOH ethanol. Then we have, if you have NH4HS, right? These are some specific reagents that you have. Because what we can see that they are asking you questions based on these reagents. These are some specific reagents based on which they have asked the question, right? Okay, understood? Yes, everybody. Yes, Khushi, Sabrinath, Subbu, Maheshwari, right? Tell me. Understood? Acha, now will you be able to answer this? Any idea? If I talk about total number of reagents from those, and nitrobenzene can be converted to this. That means Nitrobenzene means aromatic ring you have that is being converting to this thing. Now guys, any idea about it, what we will do here? Any idea about it, what we will do here? Now, if you talk about zinc, HCl, iron, HCl, this so I have told you. Now, which one is better? Which one is better? Fe or Sn? Tin or iron? Which one is better? You're saying 5, someone is saying 3, Marvel is saying 3, ma'am. Khushi is saying, ma'am, 5. Very good. Now tell me, what are those 5? Right? Booth will show. This one also, catalytic hydrogenation, also we saw that it will convert NO2 to NH2. Zinc HCl. Now, any metal you have with HCl, that is going to reduce. You have zinc, you have iron, you take zinc, that is going to convert NO2 to, that is a good reducing agent, NO2 to NH2, right? H2 rann nickel, that is also kind of catalytic hydrogenation only, right? Specific catalyst you have used here. But what about this one? What about this one? Or tell me what it is going to give you. What it is going to give you. We talked about that if you have NO2 and you give here tin NH4OH. Achha, now here students will be like, but ma'am, you said ma'am this should be zinc only ma'am, but here it is tin. Zinc you take, tin you take, iron you take, any metal with NH4OH or NH4Cl, because this eventually is going to make NH4OH. NH4Cl with water is eventually going to make NH4OH. So you are getting this OH from this water or this base here, right? So that's why this is directly going to give you, that is the same thing only, it is going to give you NHOH. So that is why answer is going to be these 5 are going to give you nitro. This one is not going to give you nitro. So answer is yes. 7890, what is that? 13456. 13456. Definitely yes. Acha. Very good, Manoj. Huh? Counting you want to do here in the class. JE, they will ask you 1, 2, 3, 4. Do the counting of 1 to 100 and they will give you IIT. Huh? Now tell me, ammonolysis of alkyl halide. Now this you must have done so many times. Ammonolysis of alkyl halide. You have alkyl halide. How it is getting converted to, when you add ammonia here, it gives primary, then secondary, then tertiary, then quaternary. That is ammonolysis, right? So if you talk about breaking of CX bond, right? Carbon halogen bond by ammonia is called as ammonolysis. So breaking of CX bond by ammonia is ammonolysis. This is a nucleophilic substitution reaction. And if you see this is a nucleophilic substitution reaction where a nucleophile is electron rich. It is electron rich and it is going to attack on the electron deficient position. So what you have here, you have Rx here, right? And you have a nucleophile that is NH2, NH3, that is ammonia. This is the nucleophile where ammonia molecule is attacking as nucleophile. So this with the lone pair is going to attack over here. It is going to attack. Now, which position they will attack? This is partially positive. This is partially negative because this is more electron negative. That is why this is going to attack here on this position. And here this will leave from this side. Right? Okay, and that's how you will have the formation of R. This is N, and that has 3 hydrogens, 1, 2, 3, and that is why there is a positive charge over here. And after that, what will happen? This will also leave from this side, this will shift here, and hence in the end you will have the formation of N with 1 lone pair, and you will have 1 alkyl group and 2 hydrogens here, that is primary amine, right? Okay, primary amine we know how it is happening, right? Now, in this case, nucleophile attacks of NH3 on alkyl halide, and this is what you will have. Substituted ammonium salt is formed, and after that, primary amine is formed. From primary, again, primary amine will react here, right? It will attack here. Again, one hydrogen will leave, and you will have the formation of secondary. Again, this secondary is going to attack here. Again, this X and one hydrogen will leave, and you will have the formation of tertiary. Again, this is going to attack here, and here you will have the formation of quaternary ammonium salt. That means this nitrogen will have this Rx, and it will have 3R here, and that is positive, and this overall you can say this is going to be X negative. Like this is your quaternary ammonium salt that is formed in the end, right? Yes. Okay. Understood? Now, let's talk about the free amine can be obtained from ammonium salt by treatment with a strong base. Now, this is an important thing because based on this also they have asked you question in PYQ, right? I'll tell you what is exactly that. The free amine can be obtained, like what we are talking about, the free amine that you have. How you will have that? From the ammonium salt. Now, this is the salt. If you talk about the first thing, when NH3 attacked on Rx, it attacked like this. You had R with this X, and this N has 3 hydrogen with positive. Now, this became RNH3X, right? Okay. Now, how do you get your free ammonia? How do you get RNH2 from this position? That means how do you take out X negative and H positive from here? How do you do that? Right? So a simple way of doing that is adding base here. Right? So the free amine can be obtained by ammonium salt by treatment with a strong base. Right? Simply you react with the base, and that's how you will have your free ammonia. Disadvantage is yielding mixture of primary, secondary and tertiary amine. Also quaternary amine is also taken there, right? So you have a mixture of 1 degree, 2 degree, 3 degree and quaternary amines here. It's not specific. You'll be able to take out primary. Whatever kind of amine is formed, it will be by adding NaOH, you'll be able to take that out, right? Primary amines can also be obtained as major product by taking large excess of ammonia. If ammonia is in large excess, then number of Rx will be less here. So the attack of ammonia on Rx will be less here. So what will happen here? The condition, see, simple thing is, if you have this in excess, if you have ammonia in excess, firstly it will form Rx. Now you don't have any other, let's say, okay, let me just tell you here. Let's say from ammonia you have the preparation of primary amine, right? Let's say ammonia is in excess but Rx in the limitation. So what will happen? It's not like 2 degree, 3 degree will not be obtained here. It will be obtained, but let's say you have 5 Rx molecules here, and you have 100 ammonia. That is the reason you will have all the 5 ammonia will attack on Rx to have 5 primary amine, 5 RNH2. Now this ammonia does not have any more alkyl halide, right? Okay, that is the reason this ammonia, right, what it will do, wait a minute, in the excess, more alkyl group will not be there. So this cannot act as a nucleophile now, right? If you have more alkyl group, only then, alkyl halide only then that will be acting as nucleophile. Now it does not have more of alkyl halide, that is why it not be acting as a nucleophile here. So that is the thing here, that you can take large excess of ammonia. The order of reactivity of halides is Ri, then Rx. This is the constant thing. Why? Because down the group bond length increases, it is easy to break the Rx bond, and in this what we are doing is we are breaking this Rx bond. So if this bond strength is not good, Down the group, the size is increasing, so bond strength is not good. That is why this is happening here, right? Okay. Next is reaction of azide. What is azide, right? That is NaN3, sodium azide. Now what will happen here, simple is, you react it with azide, you will have the formation of RaN3, right? Then you apply, then you add, this is because in the end we want to prepare amine here. So from azide, you add NaBH4, that is also a very good reducing agent. Sodium bromohydride, right? Bromo, I am saying sodium borohydride. Okay, sodium borohydride, that was lithium aluminium hydride, and I have also told you the difference in sodium borohydride and lithium aluminium hydride. Okay, that is also very important, right? Now if you see this here, this exactly, this azide is converted to the same alkyl group, but then two nitrogens are replaced by hydrogens here. Mechanism and all is not important for this particular reaction for you. Just remember the reagents here. That alkyl azide, when you have azide means N3, then you use reducing agent, that is NaBH4, and directly that is converted to primary amine, right? Now let's see this JEE 2021 PYQ, that is ammonolysis of alkyl halide followed by treatment with NaOH can be used to prepare primary, secondary and tertiary amines. The purpose of NaOH in the reaction is what? Tell me. The purpose of, yes, ammonolysis of alkyl halides followed by treatment with NaOH solution can be used to prepare for primary this and this. The purpose of NaOH is what? To remove acidic impurities, to basic impurities, to activate NH3 in the solution, to increase the reactivity of alkyl halide. What exactly it does? So what you have here is, you have N which has 3H and it has 1 Rx, that is there, right? So this is positive, right? That we want to remove H and this. So in this case, what exactly we are doing? We are adding NaOH, okay, and we are converting it to primary amine. So what exactly we are doing here is, we are removing the acidic impurities here to get the primary. Only then we'll be able to get primary free amine here, right? So what we are doing here, right? You have this, you have this. Now what all you have here is, you have the removal of HX here. What is this HX? That is acid, right? So that's why during the reaction HX is formed, we use NaOH to remove the acidic impurities here, right? So answer is going to be A is the correct answer, because what we are doing here, if you see this here, this X and this H is removed here. That is removal of HX, which is an acid in nature. So answer will be, to remove acidic impurities, we do so. To neutralize HX, that also you can say, right? To get free amine, that also you can say, right? Next is acid with ammonia. How acid reacts with ammonia? Let's talk about this. So this thing is called as phthalic acid, right? This is called as phthalic acid. And we want to prepare phthalimide from it. We want to prepare phthalimide, that is because we have Gabriel phthalimide reaction in our syllabus. So sometimes they don't directly give you phthalimide, they give you phthalic acid. So you must know what is phthalic acid, what is phthalimide, and how they are interconverted to each other. So this you have, this is called as phthalimide, right? This is called as phthalimide. And this reaction is very, very important, Gabriel phthalimide reaction. Firstly, let's talk about, let me just write it here. This is phthalic acid, right? And this is phthalimide. Okay. Now let's talk about this. Phthalic acid, you add ammonia here. what will happen whenever you have, now remember one thing, whenever you have C double bond O, OH, to convert it into C double bond O, NH2, you add excess of ammonia, right? Then this is converted to amide, or you can just simply say that when you add ammonia here, that is converted to amide here. How it is converted to amide? First you have C double bond O, right? And here ammonia is attached here, that becomes NH4 positive, right? Now after this, water is being removed from here, 2 hydrogens here, 1 oxygen, 2 hydrogen, 1 oxygen. This becomes C double bond O, NH2. Or you can just directly remember that whenever you add ammonia, you have the formation of, in acid, whenever you add ammonia, you have the formation of amide. That is a very important thing to know, right? Now after that, all you have to do is you have to take out the, you just have to heat it. So you will take out NH2, and this is 3. NH2 is taken out, 1 hydrogen is taken out, total NH3 is taken out, right? That becomes NH here. So here what you have, this is called as phthalimide. Okay. Now why we are discussing this? Because we want to know how Gabriel phthalimide and how preparation of amines from Gabriel phthalimide reaction occurs. Okay. Yes, tell me. Tell me. Right now, this is a very important reaction. This is a very important reaction, right? Good method to form primary aliphatic amines. Remember this thing. Now the question, assertion, reasoning questions can be asked on this thing. First thing is, only primary amines are formed. Only primary aliphatic amines are formed. Aromatic amines are not formed here. The answer lies in the mechanism, and this mechanism is like very simple, like simplest mechanism you have, right? So because mechanism is not that much in detail, so we'll talk about this mechanism here, right? See, KOH you have, K positive, OH negative you have here, right? What will happen? What will happen? This H will be replaced by this K. Then you have here, you can just replace this H positive. Otherwise, what will happen? There is SN2 attack, right? This is the lone pair of electrons, right? And here you have R over here. That will, as a nucleophile, it will attack here. It will take out K, and then it will form NR, right? That's how it will be done, right? But that much detail you don't have. So simply remember one thing, right? That firstly K positive is replaced, then R is replaced with K here. After that, what you have in this case, what will happen once you add NaOH here? I'll just show you this here only, right? Once you add N, this is Na positive, this is OH negative. So this particular bond will break. This is O, this is NaH, because this is aqueous, no? So here what will happen? This H positive will be here, this H positive will be here, this ONA will be here, ONA will be here. So you will have the formation of C double bond O ONA, C double bond O ONA. This is RNH2, right? So that's how you have the formation of primary amines here. Now, first question is, ma'am, why you said only primary amines will be formed? Because if you see this particular reaction here, this bond will break, this bond will break. Here you have H, here you have H. So you can't attach one more alkyl group here. So there will be always 2 hydrogen and 1 alkyl group. That is the reason always primary is formed here. The second question that you can ask, ma'am, but why, ma'am, aromatic cannot be formed? If you see this here, what is happening here? What is exactly happening? We are breaking this bond. This RX bond will break. That means it should be easy for us to break this bond. If you talk about chlorobenzene, whatever benzene you talk about, what will happen? Because of the resonance, they will have a partial double bond here, right? They will have a partial double bond here. That is why it is difficult to break this bond. Moreover, this is nothing but this is sp2. That is the reason it is difficult to break this bond. Moreover, when you break this, you have the formation of this thing, which is obviously, chalo theek hai, that is SN2 mechanism. Phenyl cation is not formed, right? But it is difficult to break this bond, right? Because of partial double bond resonance, right? That is the reason you will never use this R. This alkyl is coming from this RX, so you can never use benzene here. That is why there can never be the formation of aromatic primary amines here. So aromatic, not aldehyde, this will be amines, okay? Little mistakes. So this will be aromatic amines can never be formed. Aromatic amines can never be formed here. Right, guys? Tell me, everybody. Right? Okay? Aniline, because it's an aromatic amine, that is why it is not formed in Gabriel phthalimide reaction. Acha, now let's see this question here, that is, which of the following compounds can be prepared in good yield by phthalimide synthesis? Right? Okay? Which of the following compounds can be prepared in good yield by phthalimide synthesis? Which can be prepared in good yield by phthalimide synthesis? Right? Right? Okay. Yes, everybody. Tell me. Now, last notes, you didn't get the notes. Acha? I'll see if it is not uploaded or not. Right? So, which cannot be, see, this aromatic cannot be formed. If you see this here, this is amide, and nowhere we talked about amide here. We only talked about primary amine. This is secondary amine. This also cannot be formed, right? This is primary, because this is also not aromatic. Nitrogen is not attached to benzene ring here. So this will be formed in good yield here. So answer is B is the correct answer here, right? Okay, understood? B is the correct answer here, right? Next is J 2019 question here, that is based on this. The increasing order of reactivity of the following compounds towards the reaction of alkyl halides directly. So they are asking you the order of alkyl halides here. Who will tell me the answer here? Let's see who will tell me the answer here, right? Okay. Okay, yes. Tell me. So the increasing order of reactivity of following compounds towards the reaction with alkyl halides, right? That is what? Towards the reaction with alkyl halides. So alkyl halides, if you see, more is the lone pair, because that's a nucleophilic attack. More is the availability of lone pair, better the attack, right? So that means what we want, yes, we want the lone pair there on the nitrogen. If you talk about this lone pair, this is already delocalized. This lone pair is delocalized in two carbonyl compounds here and here. So I can write this is delocalized here as well, right? So two delocalizations. Here you have only one delocalization, right? Here you have delocalization over here as well, and here you have delocalization. If you take it here, this is only here with the benzene ring. Here also you have it with the benzene ring, but you have CN group also, that is showing you electron withdrawing effect here, right? That is the reason that here more effect will be there. So out of this minimum I would say delocalization is in the case of D. So D has to be very good in this. So that means D can show very good reaction of ammonolysis. So D is maximum here and here. So these two are already eliminated, right? and then I talk about D is already there, then that is already deleted. What you have there after this, you have C, B and A, right? In this case, two delocalization are there. After D, here you have with benzene, and you have only little minus I effect here, right? So here you have delocalization with this, and after that it is also delocalized over here, right? So after D, you can say there is C, right? Because that is less. Now in these two conditions, which is more? B is definitely more, right? Because B has two delocalization with the carbonyl, and here it is only one, so it is going to be DCAB. So answer is DCAB. So answer is B is the correct answer here, right? Okay, everybody, tell me in the chat box if that is clear to all of you or not, right? Yeah, I'll give you the break, don't worry about that, right? Don't worry, I'll give you dinner break, right? Okay, so answer is going to be B is the correct answer here. Is that clear, everybody? Is that clear? Do let me know if that is clear, right? Then you have Hoffmann bromamide degradation reaction. Again, a very, very important reaction. Its mechanism is itself very important, right? So both things are important. Mechanism is important. I'll tell you, it's not like they ask you question from mechanism. As of now, though, it's not like they have asked, but still it is a very important reaction, and mechanism, they can even surprise you with that. So you must know the mechanism, right? Okay, because of this place migration of alkyl take place. Now this particular step is very important here, that's why I'm asking you to do this. Now preparation of, I told you that you have RC double bond O NH2, and here what will happen in Hoffmann bromamide degradation, this CO will eliminate only, and you will have the formation of one carbon less, that is, it is degradation, one carbon less primary amine is formed here, right? Okay, yes, everybody, tell me. Done. Now if you talk about this thing here, the amine so formed contains one carbon less than that present in the amide. So you have this one that is present in the amide. So one carbon less will be found. What are the reagents? Br2NaOH, that is the reagent. You will have the formation of sodium carbonate and NaBr and water as the byproducts. Now let's talk about the mechanism, that what exactly is happening. See, you have the base. Now what is the work of a base? Tell me what a base, what it does. Because here one step is very important, a very good rearrangement takes place here. That's why this mechanism is so important, right? So if you talk about base, its work is to abstract proton, right? So it is going to abstract the proton. So base is going to abstract proton. So it is going to abstract proton. That is the work of a base. So how does it abstract proton? It will attack here. It will take out proton from here, or you can just simply write it like this. It will take out proton here, right? Okay. Acha, tell me, when proton is taken, bond it will not take from there, no? Bond it will not take. This is because of the base, this is happening, right? So that is the reason the electrons that is covalently bonded to this hydrogen, they will be shifted somewhere else, right? Let's talk about that. This base is going to take out the proton from here, right? And then what will happen? This is going to attack here, right? Or you can just simply say this particular electron is going to shift here, the bond is going to shift here, and these electrons are going to shift here, right? The pi bond is going to shift there. Now what you have, C double bond N, and this is O negative, right? Now till now you know what a base has done. Now you have Br, which is actually, there is no electronegativity difference, But in one point, there will be one that is partially negative, partially slightly more positive at some instant. And at that instant, what will happen? Because of this pi bond here, pi bond has electrons, it is going to attack on that particular point where electron distribution is less. In a bond, electrons are moving at one instant. This particular Br, bromine, has less electrons and this has more. At that one particular instant, what will happen? Right? What will happen? This pi, this is partially positive, this is partially negative. So what will happen? They are going to attack here, and this Br, because this is partially negative, so that is why it is going to take out the Br from here. And once this pi bond has shifted, this carbon is again with 3 bonds. That is why this negative will again shift here. Got it or not? Tell me guys if you got it or not. I'll just show you the arrows again here. What is happening here? Tell me. Pi bonds you have here between nitrogen and carbon. Those pi bonds are going to attack here. Those pi bonds are going to attack here because this is partially positive. And here Br negative will leave. So you can say Br negative will leave, right? And that is the reason this negative charge that you have over here, that negative charge that you have over here, that will attack here. So you have this negative charge, this is going to attack here. So you will have Rc double bond O. This is N. To this nitrogen, right? You have the connection of Br here, one Br and one hydrogen is there, right? Again, what we have done, one thing we have done here. Firstly, a base is going to abstract the proton, right? When a base is going to abstract the proton, you have this thing. So with this pi bond, because of this pi bond, Br attacks here and you have the formation of this thing. Now tell me if that was clear to all of you or not. Okay? If that is clear to all of you or not, do let me know in the chat box. Till here, this one step is very difficult, that we will do next. Not next, next to next, right? Till here there is no problem, right? Yes. So now again you have a base. Again the same thing will happen that we did there. Base is going to abstract the proton. So base will abstract proton here, right? This bond will shift here and this bond will again shift here. So again what you will have this thing. Now a very important thing is going to happen here. Okay? O negative you have here. A very important thing is going to happen here. This is the most important step. I'm drawing this by blue, that what is exactly from here to here, this is the most important step, that what will happen, right? Let's talk about that. What will happen here, right? This particular negative will shift here, right? And when it is shifting here, instead of this pi bond shifting here, what is happening? This entire R is going to shift on the nitrogen. So you will have Rn double bond C double bond O, because here Br negative is going to go. Understood? I'll tell you what exactly we have done. This particular, I'll just draw this with red. This particular bond is going to shift here. Negative is going to shift here. Now see what will happen. Now see what will happen. This is rearrangement. It's not just pi electrons. The atom is changing its position. That is rearrangement, right? So what will happen? This R here, that will shift to this particular nitrogen, right? And this Br will shift here. There is no shifting of pi bond of carbon and nitrogen. And why then you have R this? Because this R is connected to the nitrogen. So you have R connected to nitrogen. Nitrogen is connected to double bond C. C will be connected to double bond O. And that's how you have R and double bond C, double bond O. That is a very, 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 very important step. That is a rearrangement step. Okay? Rearrangement step. Okay, rearrangement of, that is migration of alkyl halide takes place here, right? Okay, chalo, done. Okay, yes everybody, shall I move ahead, shall I move ahead? Right, and after this you have RNC double bond. And I'll tell you after this to this how it is formed, right? That I'll tell you from this question itself, right, how it is done. So you have the formation of RN double bond C double bond O, right? Till here though it is the same thing, right? After this I want to tell you that what exactly will happen. Okay, after this let's see what exactly will happen. OH negative, because we are adding water here, we are saying that after adding just water, HOH, you are going to have amine. But how you are going to have amine here, let's talk about that. It's a very important thing that when OH negative attacks, it will attack on the electron deficient species, that is this one, this is negative, it is there. Now these pi electrons are going to shift here. These pi electrons, OH negative will attack here, pi electrons are going to shift here. So here you will have COH and this will be double bond O. This will be, sorry, O negative. O negative. This is RN double bond C. Okay, this is the thing that you will have. Now this particular pi electron, this negative will shift here and this will shift here, and you will have Rn negative, this is C, this is OH, this is double bond O. And after that guys, what will happen, this particular bond will further break and you will have the proton transfer. This particular H will transfer to this place and here you will have RNH. Yes, right, and carbon dioxide will be eliminated from here. This bond will shift here and you will have the elimination of carbon dioxide. So what will happen, proton transfer is going to take place, and after that carbon dioxide will be eliminated and here you will have the formation of RNH2. Okay, so that's how a primary amine, this is also specific for primary amines, so that's how primary amines is formed here. Right, everybody, do let me know in the chat box if that is clear to all of you or not. Right, okay, so that's a small step in the end, but major important step is this one. Major important step is this one, because that's where students have problems, right? That is a rearrangement step you must have, you must know. That is why I taught you this mechanism, because other things are okay. There's a very different mechanism apart from other mechanisms, right? Okay. So now let's see this question here. That is, the question says that JEE 2022 question, that is the reaction of RC double bond O, right, with bromine, and this give this as an end product. Which of the following is the intermediate product formed in this reaction? So what we have done, the intermediate product was R connected to nitrogen and then nitrogen connected to double bond C double bond O. So answer will be C is the correct answer. This was formed as a intermediate, right? This was formed as a intermediate over here, right? Okay, yes everybody. Acha, now let's talk about basic character of amines. Basic character of amines. Let's see how basicity is defined for amines. Yes everybody. Done. Let's see basic character of amines. Amines are basic in nature. Like you have ammonia, like ammonia, amines are also basic in nature. The basic nature of amine is due to the presence of unshared pair here. Unshared pair, like lone pair of electrons on the nitrogen atom. So just understand one thing, that basicity is defined by, basic character is directly proportional to availability of availability of availability of lone pair. Availability of lone pair. It means it directly depends upon electron donating group, and it is inversely proportional to electron withdrawing group. Right? This you must remember, and you'll be able to answer the questions based on basicity here. Right? So firstly, let's talk about that how the lone pair is going to show the, because of lone pair it is basic. So if you see that this is base, and that's why when it reacts with an acid, from because of this lone pair it attacks here, and this accepts the H positive from here, and that is why it has the formation of salt. Whenever an acid and a base forms a salt, that is definitely, that shows that this is basic in nature. Right? Similarly, aniline is also doing the same thing. It is going to give you N, this accepts H, and this is Cl negative here. So this is NH3, N positive H3 Cl negative. That is also forming a salt here. That means these amines, anilines are basic in nature. That is a proof, because they are giving you the salts here. So alkyl amines 1 degree, 2 degree are stronger bases than ammonia. That also will talk about why alkyl amines are stronger bases than ammonia. So if you see in ammonia, you have 3 nitrogens connected. But in case of alkyl amines, you have this plus I effect of the alkyl, right? Because of the plus I electron donation effect of this alkyl here, what will take place? Here electron availability will be more on nitrogen, so it will be a good base, right? If let's say you have 2 alkyls here, then more electron donation is there, more availability of electron. Let's say you have 3 alkyls here, then you have even more donation, right? So what you're going to say here, that 1 degree, 2 degree, 3 degree amines are definitely a stronger base as compared to ammonia, right? That is reason you can say, because of plus I effect of alkyl group, right? Basic strength explained in term of electron releasing inductive effect of alkyl group. The electron density on the nitrogen atom is increased by the plus I effect of the alkyl group. Alkyl amines can donate lone pair of electrons more easily than ammonia. That is the reason ammonia is less basic. This is ammonia. That is less basic than 1 degree, 2 degree or 3 degree amines. Right? Okay, everybody. Now, ma'am, what about 3 degree, 2 degree and 1 degree amine? What about them? Which one will be more basic? So, let's talk about this in more detail, right? Because because of plus I effect, you can say this, but this varies, right? Okay. This varies according to aqueous or gaseous medium. So, let's talk about that, right? So, if you talk about, let's first see, this is in gaseous medium. In gaseous medium, though, there is no tension, right? You can just simply say that in gaseous medium, always more, because there is no water here, right, to interfere in between. There is no water here to interfere. That is why it is more the alkyl group, more is the basicity, more is plus I effect. This has 3 alkyl groups, so 3 plus I effect. It has 2 alkyl groups, so 2 plus I effect. It has only 1 alkyl group, so only 1 plus I effect. Here there is no alkyl group, so there is no plus I effect over here, right? Okay. That is the reason you can say that according to this, right, according to this gaseous, 3 degree, then 2 degree, then 1 degree, then ammonia, that is going to be your state here. That is going to be your basicity here. But in case of aqueous solution, things are quite different, right? Let's talk about how in case of aqueous medium, things are so different here. Let's talk about that. Yes, everybody. So how things are different in case of aqueous medium, let's talk about that. Yes, student. So in case of aqueous medium, there is hydrogen bonding. So extent of hydrogen bonding in water and order of stability of ions by solvation is different here. So here what you have, This is the hydration, this is the hydration, this is the hydration effect of primary. Because hydrogen bonding, for this oxygen to show hydrogen bonding, the oxygen or water can only show hydrogen bonding with hydrogen, not alkyl group. So here you have three hydrogens, so three hydrogen bondings are there, right? So I'll just mark the hydrogen bondings. This is one, this is two, and this is three hydrogen bondings. Here you have two hydrogens, only two hydrogen bondings are there, right? Here there is one alkyl group, so only one hydrogen bonding is there. Can you see this over here? Can you see this, everybody? Right? So here you can see in 3 degree less is the hydrogen bonding. So according to this solvation effect, so basic nature of aqueous phase depends upon three effects. First is inductive, then there is solvation, then there is steric hindrance. Right? That is why the answer differentiates here. So based on inductive effect, we know that the basicity of this is maximum here. Based on inductive effect, more is the alkyl group, more is the basicity because of the electron donation, right? And if you talk about this aqueous, if you talk about, I'll just write the, wait a minute, I'll just write this here. Because of solvation, what will happen? Because of solvation, what will happen? Three hydrogen bonding means more energy is released here. So according to solvation, it should be 1 degree, then 2 degree, then 3 degree. Okay, I'll just write it here. Okay, I'll just write it here, right? Huh. So, yes. Okay. Huh. So based on inductive effect, this one is more, this is based on inductive effect because of plus I effect here. Because of solvation, we know that solvation is maximum in primary. So according to that, basicity of primary should be more, they are opposite. According to inductive, 3 degree should be more. According to solvation, 2 degree, 1 degree should be more. What about steric hindrance? Hindrance is maximum here. So that is why more steric hindrance is here, and here you have less steric hindrance. More steric hindrance means this lone pair finds it's very difficult to attack. Here lone pair is free. It is available for attack. So according to steric hindrance also, it should be this. According to solvation, it should be this. According to inductive effect, it should be this. So based on the overall effect, we have specified, not we, the scientists have specified for primary, for methyl, if you take R as methyl and ethyl, the answer differentiates, right? And they will only ask you whether for methyl or ethyl. Nothing else they will ask you in the exam, right? So they will ask you in the aqueous medium. See, if they ask you gaseous medium, just write primary, secondary, tertiary. Then don't get confused in gaseous medium. If they ask you aqueous medium and they gave you that, okay, you have methyl substituted amine. In that case, remember that it is 213, right? In case of ethyl, it is 231, right? And ammonia is definitely in the end. 213, 231. Just remember this thing. For methyl, right? 213, right? 213 is for methyl. For ethyl, it is 2. 2 is there only, it is 31 here. You can remember for one of them. I remember for methyl, it is 213. Okay, just remember that thing. Right, everybody? Let me know in the chat box and spam it over there in the class, in the chat box. What is exactly there? Right? Okay. Yes. Now here, next one is ammonia is more basic than aniline. If I talk about ammonia, why it is more basic than aniline, right? So what exactly happens in case of ammonia? You have NH3, right? Here, okay, see, first thing is you have ammonia here, right? That has lone pairs as it is. but primary, secondary and tertiary amines, because of plus psi effect, because of so many factors, right, they are going to have more basicity, and anilines have less basicity as compared to ammonia, right. The reason here is simple, that is because of the delocalization of these electrons. So availability is less here. If you see delocalization, this lone pair will jump here, will jump here. It is overall delocalized in the ring itself. Because of this delocalization here, what is going to happen? This particular lone pair is not available for the not available. I'm not going to draw the structures here because that I have already taught you in GOC, right? So not available for availability, you can say not available nahi, we can say availability is less, availability decreases. In this case, availability of electrons will decrease here. Okay, is that clear? Yes, students, tell me. The availability of electrons will decrease here, right? Now, so that means, as I told you, that basicity depends. As electron donating groups are there, that will increase the basicity. Electron withdrawing groups will decrease the basicity, right? Electron, it is directly proportional to electron donating and inversely to electron withdrawing groups. Now, if you see this thing over here, in this case, if you see, this OCH3 is actually donating. This is showing plus I effect and minus I. Plus I is more dominating. That's how GOC is important for you. This shows minus I and minus M. That is why it is electron withdrawing. There is no effect here. Here, because of its plus I, it is going to increase the availability of lone pair. It has no effect and it is going to decrease the availability of lone pair. That's why maximum, then less is the order of basicity here, right? Now let's see a question of JEE Mains 2025. A very simple, direct question they have asked you, right? The correct order of basic nature in aqueous medium. So what they have specified here, aqueous medium, right? They have given you ethyl here. This is ethyl, and in ethyl, what we know? We know it is 231, right? So if you talk about ammonia is less, then dihydrazine is also less because there is no alkyl group that is available. Here you have only one nitrogen availability which has lone pair of electron. Here you have two nitrogen which has two lone pair. But there is no alkyl group here. So that is going to stay like this, right? But if I talk about primary, secondary and tertiary, so maximum is secondary, then tertiary, secondary, then tertiary, then primary. 2 3 1. Okay, so answer is going to be 4 is the correct answer here, right? Answer is 4 is the correct answer here. Okay, that was a very easy question, right? 2, it's not 3 2 1. No, it is 2 3 1. So it is secondary. This is tertiary. This is primary, right? So it's a very simple question, very easy, very direct question. You just need to go through the chapter once. If you've gone through that, then definitely this is not a difficult question to answer, right? Okay, right? Now next question is JEE 2023 question that you have over here. Now based on JEE 2023 question, what you have here amines, right? And then you have pKb value here. Let's talk about this, how you're going to answer this, right? Let's talk about this, how you are going to answer this thing here, right, everybody? So if I talk about aniline here, right, one thing is, in case of aniline, let's talk about one thing, that Kb is inversely proportional to pKb. So firstly, I'll write the order of Kb here. Aniline, see, this is ethanamine, this is again ethanamine, okay. Aniline is going to be minimum, so A is going to be minimum, right? Ethanamine is nothing but it is C2H5, NH2. N-ethylethanamine means nothing but NH. This is C2. There will be C2H5 twice NH because N-ethylethanamine. N-ethyl means, what do you mean by N-ethyl means this hydrogen that you have in amine is replaced by ethyl part. Okay, that's why this thing. N-dimethyl means you have nitrogen that is replaced by two this is thrice, this is okay. Now, keeping in mind that they have not mentioned here it is aqueous, right? So I'll just directly write Kb is maximum for tertiary, right? Then C, then B. So DCBA. So answer should be DCBA. A should be maximum. Okay. Now they have just asked you match the following, not increasing, decreasing order. A is A is maximum. Maximum value is this one. So maximum is for third. Okay. A is maximum. So D is eliminated. We have to find the value of B here. With B only, I think it should be 2. Right. Let's see. B is ethanamine. Then after this, you have C now. C is the lower value, then that is fourth. Right? Me. After A, you have B. After A, you have B. B is lower value, then that is 4. B is 4. B is 4, na? After that, you have C. A, B, is it A, B, C, D? A, B, C, D. After that, I'm just confused about one thing. They have not specified aqueous, so it should be gaseous, according to gaseous only. So then answer, if I write here according to gaseous, not according to aqueous, right? But they have also specified ethanamine here. So let's see which permutation combination suits here the most. Okay? Because they have not specified, so I'll apply both permutation combinations here. If I say A is definitely third, if I say in case of, I take gaseous medium, B is fourth, then B will be fourth, and then C should be first. And there is no option like that. Okay. There is no option like that which justifies gaseous medium, right? So they have not given you gaseous medium, but there is no option that is justifying. If you see this here, B should be less than that. So it should be like 9.3. This should be 3.29. This should be 3.25. This should be 3. So it should be 4. It should be, no. It should be third. It should be fourth. It should be first. It should be second. But it is not there. There is nothing like that you have here. Like if C should be 2, then if you write it, then C should be 2. Right? But it is not like that. I've written the opposite here. Wait a minute. This should be 9.3. This should be maximum, na? So it should be 9.3, then 3.29, then 3.25, and then this is 3.0. So this is 3. This is B is 3.29. That is 4. C should be first, and D should be second here. But there is no possibility, so that means this whole is not true. There is no option like that. That means without even giving you that this is aqueous, they are saying that this is aqueous. So they are talking about aqueous here, right? So you can see 2023 and 2025, they have asked you same question only. The way of asking it is different. So it should be 2, 3, 1. So it should be aniline is minimum. Maximum basicity is for 2 degree, that is C. Then 3 degree, that is D. Then 1. 2, 3, 1. 1 is B. Right? That means pKb value has to be opposite. A is maximum, then B, then D, and then C. Maximum is defined for 9.3. Then B should have 3.2. Then maximum is for this na B 231B. Huh. So D should be what? D should be equals to 3.25, that is 1, right? 3.25, right? You can write 3.29, this is 3.0, this is 4, this is 3.9, this is 3, this is 4, and this one is 1, and this one is 2. Right now, see, now this pattern is getting okay, right? That means that they were talking about aqueous medium here, right? So I had a feeling that they are talking about aqueous medium only, right? Okay, because especially they are saying na ethane, so you can get an idea that okay, ethane or methyl if they have specified, but still don't fall into that trap. Firstly, see if they have not mentioned, right? Then gaseous can also be the answer, right? Because here there is no option that is giving you the answer for gaseous, so that means aqueous is the correct. Now ma'am, what if gaseous and aqueous both are in the options? That will not be there. If it is there, then it's their fault, then that will be a bonus question, okay? Because they should have specified this to you, right? Okay, yes, okay. Now next is reaction of amines. Let's talk about the next part, that is reaction of amines here. Yes, everybody? Because of ethane presence, yes. Now let's talk about acylation, right? Acylation or acetylation. When on the amines you add these compounds here, let's see how. Aliphatic, aromatic, primary, secondary amines react with acid chlorides. Whether you have primary or secondary, no tertiary, primary and secondary reacts with acid chlorides or anhydrides by nucleophilic substitution reaction to form amide. Let's see how they form amide. Okay, this reaction is carried out in the presence of pyridine. This also will talk about why pyridine is required here. This also will talk about. Then base removes HCl, so form and shift the equilibrium to the right side. That also will talk about. Let's see. So this is the acyl chloride or anything. Now based on this also you will see, this is a simple question only, but you will see so many questions based on this very simple thing, that you have acyl chloride or ester, whatsoever it can give you this particular nucleophile. If this particular thing they can give you, that means you can simply say that it is possible, right? So if you see, this is C double bond O Cl, right? That is the alkyl part here, and you have a base here, right? Now what is going to happen? These lone pairs are going to attack here on the carbon. Now if you see, this is carbonyl carbon, this is partially positive, this is partially negative. So this is the nucleophile. It is acting as a nucleophile because it has lone pair of electrons. It is going to attack here. This is going to make nitrogen. 2 hydrogens are already there and 1 C2H5 is already there. One new bond has been formed, that is this particular bond. A new bond has been formed here. You can write this new bond over here like this. Okay, a new bond has been formed. You can write it like this. Okay, a new bond has been formed. Now if you see this here, nitrogen has 4 bonds, that's why there is positive here. Carbon cannot form 5 bonds, that is why when this attacks here, 1 2 3 1 2 3 4 5 bonds, that's why this particular bond will also shift here, right? So you will have carbon has 4 bonds, this is O negative, and that's the situation here. Now whenever oxygen has negative, it will, in all the mechanisms you will see that oxygen is giving back, giving back, giving back. So oxygen is going to give back this, and this Cl negative will be eliminated from here, right? Cl negative will be eliminated. So now what you have C2H5, this nitrogen here, this H will be eliminated, this particular bond will shift here. You have C2H5 NH C double bond O, CH3. So overall what you have done, you have replaced this particular hydrogen with this acyl group. So what you have done, you can say hydrogen is replaced by, overall is hydrogen is replaced by acyl group. Acyl group. That is why it is called as acylation. Right? What is acyl group? That is CH3 C double bond O. That is the acyl group. So you have replaced the hydrogen with the acyl group. Right? Okay. I don't know. Was it not uploaded? If it was not uploaded, guys, just give me a second. I'll just check if it was there or not. Right? I think it was uploaded only. You check the Ved link, no? In the description, you check the Ved link. You will get it. Wait a minute. It is there. Session PDF, it is in the comment section. It is there. Right? You will see it now. Okay? Yes, everybody, now it is there. Right, everyone? Tell me. Tell me, everybody. Right? Okay, so what we have now, yes, it is there, Vita. Okay, so now anything you have anhydride, just replace this hydrogen with this acyl group here, right? So that is NHC double bond O CH3, that is called as acylation, right? Now, if let's say, ma'am, this alkyl group is a benzene here, then that will be called as benzoylation. So that is simple, just the name has changed, right? So this question has been asked in JEE 2021 based on acylation itself, right? So now acylation takes place on amine. It does not take place on amide, right? Remember that. So let's talk about what will be the major product here that you will have. So we know that this will stay intact, and here this is converted to NH C double bond O CH3. Okay, so here what you will have, this will stay intact, that is NHC double bond O CH3. Here this is not true, this is intact, NHC double bond. Then what is the difference between that and this? Acha, here this one is also getting acylation. That is also not correct. This one will stay intact, right? Okay, now can you tell me why this one will stay intact, why this one will not change? Because these lone pairs are not available entirely for the nucleophilic attack. These lone pairs are already involved in the delocalization, and that is the reason these lone pairs will not give acylation reaction, right? Okay, so that's why answer will be D is the correct answer. Now this is also wrong, so answer will be D is the correct answer here, This is the same process, right? You can directly answer that, right? Okay. So answer is D is the correct answer here. Now let's talk about next thing, that is bromination. Bromination reaction. What happens in case of bromination reaction? Let's talk. Lone pair is in resonance with O. Very good. Okay. Now, in case of bromination reaction, what exactly happens? Let's talk about that. In case of bromination, a very simple thing takes place. That, ma'am, firstly tell me that whenever you have phenol, I talk to you about phenol. Now, when we had phenol, I told you a very simple thing, that whenever you have any group that has lone pair of electrons on it, it will always be plus M. That means it is always going to donate, and it will always be ortho-para directing. That means from that point, is aniline ortho-para directing or meta directing? Tell me. Is aniline ortho-para directing? From this part, can you say it is ortho-para directing? Confirmed. But there are some abnormalities that is shown by amines, right? So once you see this thing here, if you talk about phenol, if you remember, in phenol, for bromination reaction, we did two things. We said that when Br2 is in the presence of water, when Br2 is in the presence of CS2, here it will give you tribromo product, OH, Br, Br, Br. Here it can also give you monobromo product, that is para product. That is monobromo product was possible in case of bromination, in case of phenol. You don't have to do any other thing, you just have to change the reagent here, right? But in case of aniline, you will always have tribromo. Aniline reacts with bromine water at room temperature to give a white precipitate, that is 2,4,6 tribromoaniline. Now, how do you get? Only aromatic amines is very highly reactive, and substitution occurs at ortho and para position both. Now, can you tell me why they are so highly reactive? Who will tell me? Why they are more reactive as compared to phenol? They are more reactive as compared to phenol because this is aniline, right? This is phenol, right? This is phenol here. This is one lone pair, ma'am. Here you have two lone pair. Then, ma'am, how this is more reactive? Why this is more reactive? Why it is always giving you this thing? Because these lone pairs are too much available. Nitrogen is not clever. Who is more electronegative? Oxygen or nitrogen? Oxygen is more electronegative. So that is why oxygen be like, bro, I am more electronegative. That is the reason I will not be able to donate, right? Someone like rich people out there, right? So rich people, even if they have money, you will see very, it's not like always. There is a person like Ratan Tata also there, also was there, right? But usually what you must have seen is still middle class, and student people who have less money, still they will donate, right? Okay, I have this much salary, but I'll donate, right? But very rich people, they like very conjuice, right? So it's like this oxygen is like that. It is rich. It has two lone pair of electrons. It's very conjuice, more electronegative it is, right? So it will not be able to give the electrons with that efficiency as compared to this nitrogen. That is why this nitrogen is very activating group. As both are showing plus M, but it shows more plus M effect because here minus I group is not as such more electronegative, right? That is why very high electronegativity is there. Now, what you will see, that you always have the formation of tribromo, because this is highly reactive as compared to alcohol, as compared to phenol as well. And now what you will see over here. Now, ma'am, what is this, ma'am? Now let's talk about this thing here. Now, in this case, you just want to decrease the activity of the lone pair. Now you have to make the lone pair busy with something else, right? Right, Sabrinath. Now you have to make the lone pair busy with someone else. With whom? It should have delocalization with carbonyl. If it has delocalization with carbonyl, if instead of this NH, you have NC double bond O, CH3, then this lone pair is busy with carbonyl. Now lone pair, it's like when you have too much responsibilities, right? Your salary, you must have seen your parents, right? When they were young, right, when there was no responsibility on them, right, they were okay, let's invest this thing here and there. But now they have your responsibility. Now you ask them, they will never purchase for themselves, they will never do that, because they are more concerned about you, right? So before any donation they will think about you, isn't it? So this lone pair is now involved in that delocalization because of this carbonyl group involvement. That means all you have to do is you have to do, see, that acylation is also called as acetylation. Acetylation or acylation is the same thing, right? So activating the NH2 group be controlled by protecting the NH2 group by acetylation with acetic anhydride or acyl chloride, whatsoever you can use for the acetylation, right? So what will happen now, these lone pairs are busy in the delocalization, and that's why they are not that much available for the activity. And that is why when you have this activating effect of this group less than that of amino group. So that is why what will happen, because its activity effect of this group is less than amino group, because nitrogen are less available. Lone pair of electron nitrogen is less available for donation to benzene. Substituted amide on hydrolysis. Now let's see what will happen. This is the thing that we will do now. So what is going to happen now? You have aniline. This is your pyridine, and this is acetic acid, or acetic acid, I'm saying acyl chloride and hydride ester. You can use anything for the acetylation. Now this hydrogen will be replaced by COCH3. After that, when you do bromination, now only mono product will be formed. Now that is mono product will be formed, right? Mono product, right? Because activity of this nitrogen is less. Mono product is formed, para being the major product. Why, ma'am? Because of the symmetry here, right? Then what you have, then you add water, then what will happen, this thing will be again converted to hydrogen, so that will form para bromo aniline, right? Tell me everybody if that is clear. Deadly gaming, I'll ask the team if there is any problem in that, that will be resolved, okay? Yes, tell me. Is that clear? Is that clear, everybody? Now let's talk about nitration. Nitration extremely important, right? Very, very important for you. Nitration is very, very important for you. Let's talk about nitration now. Yes, everybody, do let me know in the chat box. Right? Let's talk about nitration. Right? Okay. This is very important because something very weird thing happens here, because here they can ask you assertion reasoning question for that, they can ask you direct reaction also. Acha, tell me, aniline was ortho para directing or meta directing? Aniline was ortho para or meta? It was showing you plus M effect, right? So it is supposed to be ortho para directing, or it is supposed to be meta directing. Answer me that in the chat box, right? Ma'am, it should be which one? Tell me, everybody. It should be ortho para directing or it should be meta directing? Tell me, everybody, in the chat box. Okay, ortho para. Hi, who is saying meta directing? No, it is ortho para directing. No, Shrey, it's orthopara directing. Whenever you have a group that has lone pair of electrons, then always it shows plus M effect. It's always orthopara directing. But what you can see, a very weird thing happens. So you should have only ortho and para products here. But in experiment, what we observed that you have 51% of para product, which is good. Okay, para product is there, but you have 47. It's not like 1 or 2% of meta product. You have 47% of meta product, and that is the abnormality. Why it is so? Why it is giving you meta product here, right? And ortho is only 2%, right? So first question is why it is giving you, why, first question, assertion reasoning question that they can ask you, why is it forming meta product? That is the first question here, a very important thing. See, if you see, this is an acidic mixture. This isn't it, this acidic, you have very strong acid H2SO4, HNO3. This nitrating mixture is quite acidic in nature, right? And if you see, this aniline is basic in nature. Now, what will happen? Instead of showing nitration, what they do, they are like, hey, I am acid, you are base. So acid is going to lose H positive, base is going to accept H positive, and it is going to form this anilinium ion here. That is called as anilinium ion. It is going to accept the H positive because of these lone pairs, and it forms, this is called as anilinium ion. Anilinium ion. Now you can say because of the formation of anilinium ion. But ma'am, why anilinium ion, ma'am? What exactly anilinium ion does? So let's talk about that, right? Huh. So in the strongly acidic medium, aniline is protonated to form anilinium ion, which is meta-directing. Now, ma'am, why this anilinium ion is meta-directing? Who will tell me? This is the anilinium ion. This is the anilinium ion. And this anilinium ion, guys, what it will do now? What this anilinium ion is going to do? This anilinium ion is going to be meta-directing. Why it is meta-directing? Because this has positive, electron deficient. And I told you, usually meta-directing are like this. If you have a group that is attached to with double bond with more electronegative element, this will, because this is more electronegative, it is going to take out the electron. That is why it is going to take out the electron from here. The basic reason is because now, because of this pi bond, this particular group is electron deficient. So whenever an electron deficient group is attached directly, then it is going to show you minus effect. So minus M effect it will show, and that is why this is going to be meta-directing. Meta-directing. Next question can be, ma'am, then why 100% of meta-directing product is not formed? Why only 47% is there, right? Okay, why only 47% is there? Very good, Sabra, very good. Why only 47? Because if it is directly converted, it will give you this or this. But if it is converted from aniline, then nitration, then it will give you meta-directing. Okay? Yes, understood? Yes, everybody, tell me in the chat box if that is clear or not. Right? Okay? Nitration, so we have discussed. Right? Okay? Acha. See this thing now. Wait a minute. Chalo. Now what you have mono-substituted product can be formed by protecting NH2 by acetylation. Now what we are saying You want to prepare mono substituted, you don't want to have meta product, then why, what you need to do, why this anilinium ion was formed? This anilinium ion was formed because this lone pairs are highly available. This aniline is very basic in nature. Their lone pairs are highly available. That is why this is forming anilinium ion. So if I make it busy, if I convert this anilinium, this aniline, if I convert this aniline into this thing, this is N, this is H, this is C double bond O CH3. If I do acetylation, again these lone pairs will not be available for the to make anilinium ion. The nitration can be controlled and the para-nitro derivative can be obtained as a major product. That is this thing, right? Anilinium ion, acetylation you do, then nitration you do. Now you will have only para product as a major product, right? Now after that, again same thing that we did in bromination. Add water, you will have the formation of only para nitroaniline, right? Okay, got it? Yes, everybody? Acha. Now see what we are going to do. I'm going to give you break now. Okay. This is the last thing. Chalo. Sulfonation we will do. I think, chalo, let's do this. If you have aniline, if you remember that in case of phenol also we did the same thing. If you remember in case of phenol also we did the same thing. If you have phenol, right, and you react this with K2Cr2O7, which is a very good oxidizing agent, this is going to get converted to benzoquinone. Okay, this is benzoquinone, right? Do you remember? This can also be written Na2Cr2O7. This we did in phenol as well, right? Okay, okay. Yes, now I'll see you all at 9 p.m. right? And also guys, do hit the like button on the session, right? Everybody, tell me. Done? Okay, clear. Chal. Now I'll be giving you break, and after the break we'll do the rest of the part, right everyone? Okay, yes. Chal. Now what we will do, I'll give you the break, so I'll be just, and I'll see you all at 9 p.m. now. Okay, guys? Understood? So, see you all at 9 p.m. now. 20 minutes break I'm going to give you now. Right? Yes. Wait a minute. Now I'll see you all in 20 minutes at 9 p.m. See you all and have your dinner. And after that, we'll do rest of the amines chapter and we'll do some questions and we'll do purification of organic compounds today itself. Right? Uh, so students, actually still having my dinner, right? So I just prepared my dinner. Now it will take me around 10 to 15 minutes to eat it properly, right? So I'll see you all at 9:10 p.m., right? Till then, it's the break time, right? Class will resume at 9:10 p.m., right? Okay, so see you all. Okay, yes, students, I'm back, everybody. Let me know in the chat box if you guys are also back, right? If you had your dinner. Yes, everybody, do let me know in the chat box if you had your dinner so that we can start with the session. Yes, students, let's start with the sessions, everybody. So, let's talk about sulfonation. Let's talk about sulfonation. What all is going on? Messi is lucky he was injured. Okay. Okay, guys, let's focus here, right? Yes, everybody. Are you all there or not? Do let me know in the chat box. Are you guys awake? Right? Sabrinath is ready. What about other students here? Are you ready? So, now let's talk about sulfonation. So, in sulfonation, aniline reacts with concentrated sulfuric acid to form anilinium hydrogen sulfate, right? That is, it reacts with this H2SO4. H positive will be attached here, then HSO4 negative will be here, and this is the salt that you will have, right? After that you heat it, right? Then internal transfer of the electrophile will be there, and you have the formation of you have the attachment of SO3H here, which is going to give you zwitterion, right? Now zwitterion means in the same molecule you have acid and base. So what is going to happen? This is an acid, this is acidic part, and this is the basic part. This is the basic part. So what is going to happen here, everyone? This is the acidic part, this is the basic part. So what is going to happen here, right? Basic part is going to accept the proton from the acidic part, so it will become NH3 positive and it will become SO3 negative. And that thing is called as Zwitter ion. So Zwitter ion is formed in case of sulfanic acid, right? Okay, everybody. Now, let's see Friedel-Crafts rearrangement, right? This is Friedel-Crafts rearrangement reaction. Now, in case of Friedel-Crafts rearrangement, this is a very important line. Aniline does not undergo Friedel-Crafts reaction. The question is why? Aniline does not undergo Friedel-Crafts reaction, right? Be it alkylation or acylation. Instead of this, what will happen? Acetylation will take place. Instead of Friedel-Crafts reaction, acetylation will take place. Due to the salt formation with aluminium chloride, Lewis acid used as catalyst. So basically, if you see, aniline is a base. And whatever you use is a Lewis acid. So what will happen? Instead of forming acetyl, what is Friedel-Crafts acetylation? The product should be, this is NH2. It is supposed to be when you have, let's say, CH3 COCl in presence of AlCl3. So it is AlCl3 here. Sorry, acetylation will not take place here, my bad. Acetylation will not take place. Acetylation will take place if you have CH3 COCl and pyridine, then acetylation will take place. If you have AlCl3, you will think that it should be Friedel-Crafts acylation. It should be NH2 COCH3. But this is not happening. Instead, what is happening? This is the base. This is from where you will have alkyl or acetyl group, or you can also say here it also can be RCOX, whatever it can be. This is the Lewis acid. So acid and base will react together and they will form a salt. They will show neutralization reaction instead of giving instead of this thing. It is supposed to be in acetylation, the product should be, this is NH2, this is COCH3 or COCH3 here. But this is not formed here, right? Instead, a salt is formed here, right? Okay. Achha, one more question here that I forgot to tell you here. When we were talking about acetylation or acylation, this is also called as acetylation. Acetylation. When we were talking about acetylation or acylation, I told you that in this case you will use pyridine. But why pyridine? Because pyridine is a stronger base as compared to aniline. So this CH3 COCl, right? It will take this as the base. It will not hinder the acetylation here, right? Pyridine is a stronger base. Now, ma'am, why pyridine is a stronger base? Because here nitrogen is not involved in the delocalization. Here nitrogen is involved in the delocalization, so that's why this is a weaker base. Okay, that's why pyridine was used there, right? Base removes HCl so that the reaction shift forward. And which base? Pyridine base, right? Okay, everybody. Now let's talk about some questions here. Let's see JEE 2024 question, that is, two statements are given to you. Statement number one is the NH2 group in aniline is ortho para directing, a powerful activating group, right? So what we are saying that this group is ortho para directing, which is a very powerful ortho, very powerful activating group. That is correct. NH2 is aniline ortho para directing. That is true. Aniline does not undergo Friedel-Crafts acylation. That is also true. Such a simple question is asked in JEE 2024, right? So that is, both the statements are correct here. That will be the correct answer here. Next question is 2022, and that is you have aniline. This is Br2 excess and water, and it is going to give you a product A. This is aniline. This is something acetylation and then bromination, then dilute HCl. See, if you directly form Br2 water, then tri-bromo product will be formed. So these two cannot be the answer. Tri-bromo product is formed. And if you firstly do acetylation, then bromination, then you add acid to convert. See, this is the same thing. Firstly, you convert this into COCH3. Then bromination will give you this, and then this is again converted to, with dilute HCl. It is again HCl or base, whatever you use, this is converted to aniline. So that means this product is formed here. So answer is C is the correct answer. Is that clear? Very good, Sabrinath. Very good, Ujjwal. What about others? Done, na? So answer will be C is the correct answer here, right? Now let's talk about another important part of amines, that is diazonium salt. And there are so many reactions of diazonium salt that are very important for you, right, everybody? Let's talk about diazonium chloride, how it is formed, what is the process of forming diazonium chloride, and after that we will talk about the reactions of diazonium chloride. So it is prepared from aniline itself, right? What exactly we do here? Aniline is being converted to N2Cl in the presence of what? Tell me, anybody? In the presence of, wait a minute. This is converted to diazonium salt, and this is in the presence of nitrous acid. You can say HNO2, or you can write HCl plus NaNO2. But here one thing is for sure, that the temperature is 0 degree to 5 degrees Celsius. Either they can directly give you HNO2 or they can say HCl plus NaNO2. That is the same thing here, right? Okay. Now, nitrous acid is produced in the reaction mixture by the reaction of sodium nitrate with nitrous acid is this thing, HNO2. It is nitrous acid. Okay. When you have the reaction of NaNO2 with HCl, it is going to give you nitrous acid. So you can directly write it or you can write this. But diazonium chloride is only stable between 0 to 5 degrees Celsius. That is in Kelvin, and it is written as 273 to 278 Kelvin. The conversion of primary aromatic amines to diazonium is called as diazotization. Instability, diazonium salt is not generally stored, it is immediately used after the preparation because it is only stable at 0 to 5 degrees Celsius. And to maintain that temperature, it's very difficult. That is why we are saying that it is immediately used, right? Then benzene diazonium chloride is a colorless crystalline solid. So what you have here is, it is a colorless crystalline solid that you have, colorless crystalline solid. It is readily soluble in water and is stable in cold but reacts with water when warmed. We'll talk about these reactions, it easily decomposes. So benzene is colorless crystalline solid, that is so clear. It is readily soluble in water and is stable in cold. Cold means it is stable in 0 to 5 degrees Celsius. Above that it is not stable. If you warm it, it is not stable, and you know what it will be converted to? This, when you warm it and there is some water, because it is there in the atmosphere, na? The moisture is there in the atmosphere, so it will be converted to phenol, and that's a very, very important thing. How to convert aniline to phenol? This is one of the methods of converting aniline to phenol. And here temperature is greater than 5 degrees Celsius. Okay. Temperature should be greater because 0 to 5 so it is stable, so it should be greater than this, right? Now let's talk about the correct stability order of falling diazonium salt. Can you tell me how diazonium salt will be stable? Anybody who can tell me the stability order of, very good, diazonium salt stability order? The more you give the electrons, more stability this N2 will get. So what we can say, we can write this over here. Diazonium salt contains directly linked to electron donating group. So more is the electron donating. It is directly proportional to electron donating and inversely to electron withdrawing group. That is benzene diazonium salt stability. Why? Because of this positive over here. You just need to remember this thing and now tell me the answer. Here you have, this shows minus M and this shows minus I effect, right? This shows plus M, which is more dominating as compared to minus I. Here so both are minus only, so you don't need to worry about that. Here it is showing you C triple bond N. Carbon is connected to more electronegative element with a pi bond, so it shows you minus M and minus I effect. Okay. Now tell me which one is like correct stability order. This is showing you plus M, that means this is going to donate, so A will be maximum stable. A is going to have the maximum stability, so C and D are already ruled out. Okay. A is going to show the maximum stability. Very good, very good. Acha, what about the next thing? After that you will have C because there is no effect in C. So it is A, C. So already you have your answer that B is the correct answer. You already have it. But what about D and B? Why D is greater than B? Let's talk about that. D and this is B, right? In this case also you are having minus M and minus I. In this case also you are having minus M and minus I. But you know, NO2 has more minus I effect. It has more minus I and more minus M effect. And that is why this is going to pull out more electrons from here, right, as compared to D. So D is going to be still stable as compared to B. So answer is B is the correct answer here. Is that clear, everybody? Okay. B is the correct answer. Next question, everybody, on your screen, what we have here. Next question. Yes. Very good. Carbon will not have lone pair. Yes. The major product formed in the reaction given below will be what? Now this one is interesting, and here na options are not correct. So I'll just tell you basically it should be like this, okay? I'll also explain you here. Rearrangement is going to take place, right? So see what we are going to do here. See what we are going to do here. Let's talk about that. Firstly, there is NaNO2, right? That is being reacted with this compound in presence of aqueous HCl at 0 to 5 degrees Celsius. So it is 0 to 5 degrees Celsius, NaNO2. That means diazonium salt is formed here, that we are sure about. That means this is getting converted to N2Cl, right? This is getting converted to N2Cl. But in the answer, there is nothing like N2Cl. So what exactly happens here? This is N2Cl, which is not stable. So we are assuming that they are saying that this will be taken out. So basically what I want to say, wait a minute. You will have this diazotization will take place. N2Cl is getting formed because this is unstable. This will leave, and here you will have the formation of this carbocation that you have here. Now, once you reach the carbocation, because see, N2Cl is not stable. Once you reach the carbocation, after that, what you're going to do? You're going to expand this ring, right? How ring expansion will take place? Now, this is 5-membered ring. This will become 6-membered ring. 1, 2, 3. Shift the bond of 1 and 2. Sorry, shift the bond of 2 and 3 and put it here. And this bond you will break. So it will be 1, 2, 3, 4, 5, 6. 6-membered ring. So here you will have the, where you should have the positive charge. 1, 2 on the third carbon. Wait a minute. Is it on the third carbon here? Is it 1, 2? Here it is on the second carbon. From here it is on the third carbon. Whatsoever you can write. But I will write it as the third carbon only. Because for the counting that I have written, it is coming out to be this carbon. Na? So here it is. Next to this, there is 1 and 2. So this is 1 and 2. So here it should be the carbocation. When you add water here, this will be O, this is H, this is H, this is O positive. This will leave, this electrons will jump here, and hence you will have the formation of OH here, right? Okay, so answer is going to be, this is the correct answer. As I've told you, this should be written as OH. Okay, there is only one bond here. Okay, there is only, this is by mistake. It is only one bond here. Okay, yes, everybody, do let me know if that was clear. See, concept of GOC is used here in this question. So that's why I always tell the students that GOC, why 3, ma'am? Why? Arey, nothing, it's for the symmetry. Na? I did it for the symmetry. It's the same way, you can react it same way. See, if I do it like this, if I do it like this, if I take this is 1, this is 2, this is 3, then I'll say join this bond, then it will be 1 and 2 on, then I will have positive here, right? So it doesn't matter. I have just, the way I have written 1, 2, 3, that's why I have put it there, right? Okay, tell me. That's how GOC is used here. Achha, now let's see some questions of diazonium chloride. Let's see the questions of diazonium chloride, everybody. Let's see the questions of diazonium chloride, what you have here. And this is a detailed one shot, okay? Not one shot, but yes, because I'm covering another concept here, purification. So I can't say it as one shot, but yes, you can definitely feel that I'm doing things in detail along with the question practice, everything, what kind of questions, right? It's not a revision, it's a detailed thing that we are doing, right? So if you've never done an amines, you're doing this, you're good to go, right? But every single thing that is written here, then you should not skip that. Now you have diazonium chloride, so many important reactions. First is Sand-Mears reaction. In Sand-Mears, you will use the salt, and that is copper salt. So copper salt we are going to use like Cu2Cl2, Cu2Br2 or CuCN, right? So in case of Sand-Mears reaction, you can definitely prepare cyanobenzene as well, or bromobenzene or chlorobenzene, right? In Getterman, you can't prepare cyanobenzene, but here, how do you remember? Sand. Whenever there is sand, there is salt. Sand is an ocean, right? Sand is an ocean. Ocean has salty water, so salt. Gutter is so smelly, and opposite to smell you have powder. So that's why you are using copper powder here. That's the only difference. Otherwise, the product are same. Chlorobenzene and bromobenzene are formed here, right? And in always in case of diazonium chloride, you will have the release of N2 gas here, right? Okay. Now see all these questions here, all these reactions. You have N2Cl, diazonium chloride salt. Now how you will have the preparation of benzene? You have H3PO2, you have ethanol, it will give you benzene. That's a very important reaction. From aniline to benzene, how you will convert? First aniline to diazonium, then you will just add H3PO4, or you add ethanol and you will get your H3PO2 or ethanol, you will get your benzene here. Now how to convert it into alcohol? You just warm it greater than 5 degrees Celsius, it will warm and you will have phenol. So these three we have done. Now very important thing, when you react it with Ki, you directly have the formation of idobenzene, and when you react this with HbF4, you have the formation of fluorobenzene. But if you have the formation of HbF4 with NaNO2 and copper couple, right, then you have the formation of nitrobenzene, right? Okay. And you know, this has a specific name. This I have done in haloalkanes, halorenes as well, that this has a name, that is Balz-Schiemann reaction. Balz-Schiemann reaction. So how to prepare chlorobromo, how to prepare idofluoro, how to prepare phenol, benzene and cyanobenzene from diazonium chloride. Every single reaction is important, not one, every single reaction is important here, right? Okay, understood everybody? Tell me, as I have told you, the diazonium group is replaced by NO2 group. If you react this with NaNO2 and copper couple, then this will form nitro. But this is not Balz-Schiemann. Balz-Schiemann is when you have HbF4, then you have fluorobenzene. That is Balz-Schiemann reaction. Okay, right, everybody? So now let's talk about a question PYQ, that is 2023. That is, you have okay, some A or B have they written. Let's see, this is X. In the above conversion from X to product Y, the sequence of reagents. Now this is like, you know, NCRT kind of question, right? In NCRT you have so many conversions. So all you have to do is, right, in NCRT, if you have time, then I would advise you do the conversions. You don't have to, at this point, you don't have to read the NCRT, because everything I'm covering here, but conversions part, do that. because it will help you practice the reagents. You will be able to answer this in the exam, right? Okay, so in this case, first thing is, if I see CH3, I need to firstly take out NO2. I need to convert NO2 to hydrogen. You know what's the best part? If I convert it into diazonium chloride, then I warm it. Then I add H3PO2 or ethanol. So first thing that I can do with nitrogen, that is this one. I can convert it into this. That is this particular thing. Diazonium chloride and H3PO2. I have my answer. Now how to attack bromine here, right? Okay, how to attack bromine here? So you have Fe, right? Acha, FeH positive you have, right? And then NO2 will be converted to, okay. This FeH positive, do you remember what is this? FeH positive is to convert this NO2. See, firstly I'll convert NO2 with FeHCl, if you remember, will convert it into NH2. Then this into HNO2, you will convert it into chloride. Achha, before that, we can also, for bromination, we will add Br2. Then you will have this particular NO2, right? And this is this is not NO2 now, this is aniline, right? I'll just write it here. Why I'm doing this much conjuicy, right? I'll just write it here, guys. Okay, this is CH2, this is NO2. Firstly, you react with this iron positive, that is, this is converted to NH2. That is ortho directing. That's why when you react it with Br, you have ortho product. Para is not possible here. Para position is already occupied. Then after that, you convert it to diazonium chloride, that is N2Cl. Then you convert it to add H3PO2, then you have hydrogen here. So answer is D is the right sequence here, right? No dehydration, right? Yes, dehydration, you're right. Okay, so that's how you have your answer here. Tell me. Okay? Wait a minute. Why? No, it will be H3PO2, right? Okay. H3PO2, answer will be C. Oh, sorry, answer will be D, not C. Okay, answer will be D. This one will be your answer. This one will be your answer. Right, everyone? Okay. Now you have compound A from the following reaction sequence is what? What is compound A from the following reaction sequence? You have some compound A, that is Br2CS2. Bromination is there. Then you have diazotization. Then you have this. And in the end, you have the formation of H3PO2 that will convert it to benzene. Okay. So what exactly you will have is, you will have aniline here, right? This aniline will give you, see, in aniline, whether you use Br2 water or Br2CS2, it will always form tribromo product. So it is going to be tribromo, it is going to be one second bromine, and this is the third bromine. After that, you convert it into diazonium salt. So this is N2Cl, this is Br here, this is Br here, and this is Br here. Now after that, you add H3PO2, then this N2Cl, rather than writing this, I'll write this. Okay? That is converted to hydrogen. So you have Br here, Br here, Br here. So you have alternate Brs here. That is, this compound is there. So A is nothing but A is aniline here. So answer is D is the correct answer here. Right? Okay, everybody? Got it? Yes. Now let's talk about ipso attack. What is ipso attack? Yes, not nitro. Nitro would have been there if they gave you any reduction also, that some A is also undergoing reduction, then that is undergoing bromination, right? Okay, aniline will be that one, right? This is easy. Chalo, good. Hmm. So now if you see ipso attack of electrophile, so ipso attack is the attack where what we actually assume here, you have Br2 water, you think that this is ortho position, this is para position, so product should be this thing, this should remain intact. But in case of ipso, only some of them shows ipso attack. You can see ipso attack in case of SO3H or you have COOH. In these two compounds, what will happen, this whole compound, this will be converted to Br, right? Okay, so that whole thing is converted to Br. Even here it is the same thing. Let me just write it myself, right? Okay, see what you will have here. Okay, now see this. Here, what is supposed to happen? We think that ortho and para position should be substituted by bromine. But on this position as well, you have your bromine. And over here as well, what will happen? We think that para position is already occupied, so it should be bromine here and bromine here. But this part also is converted to bromine, right? Here, this part is converted to bromine, right? Okay, that is ipso attack. Right, now let's see the next question here, that is the product Y in the following reaction is what? What is the product Y in the following reaction? Let's talk about that, right? Uh, if you have phenyl COCH3, this is NaOCl. NaOCl, okay, and this is SO2 NaOCl. This is SO2 SOCl2 and aniline. ठीक है. So NaOCl will convert this C double bond O. So what will happen here? Then you have SOCl2 and then you have aniline that is added. So let's talk about this. First, in this case, what will happen? You have NaOCl, not NOOCl. This is NaOCl, right? NaOCl that will convert this C double bond O CH3 into COOH, right? Okay. Once you have acid, then you have SOCl2, this will be substituted by Cl. And then when you add aniline into it, this hydrogen will be gone, this Cl will be gone, and you will have basically what you will have here, this will be C double bond O Cl. This is aniline, NH2. HCl will go from this side, and here you will have the formation of this compound. C, this is N. Benzene, C double bond O, NH, and this. Right? Okay? That will be the product that you will have. So answer is A is the correct answer here. Right? Now let's talk about electrophilic substitution reactions. Electrophilic substitution reaction, most of it we have talked about, right? In the resonance structure of aniline, we find the maximum electron density orthopara position, so it shows orthopara products. But in case of bromination and nitration, we saw that how it was giving you. So we have discussed this, right? We have discussed this before, right? This all we have discussed, guys. There's no need of this here, right? Okay, chalo. Now, decreasing order of reactivity towards electrophilic substitution for the following compounds, right? Decreasing order of reactivity towards electrophilic substitution reaction for the following compounds. So you need to tell me Electrophilic substitution. Electrophile is attacking. So electrophile wants to have a position where electron density is very low. So where electron density is low, there you will see that maximum attack will be there. Yes, actually, then why I deleted that slide? I could have kept it here. Wait a minute, let me just show you this through the resonating structures. If you see, in this case, electrophile will attack on ortho or para position because electrophile needs electron density, right? Such electron, I said the opposite. Electrophile is electron loving, so it needs electron density. So maximum will be there where electron density is more. Electron density increases, that means reactivity will also increase there. Okay? Where electron density is more, reactivity will be more there. Right? Okay. Now see this. This is toluene, benzene, CF3. Okay. Now let's see which one will show you maximum electron density. On the benzene ring. See, this is going to give you electrons through plus M and plus I also for methyl group, right? This is only going to show you plus M and only one methyl group is there. So electron density is more here. Here you are just taking out electrons here, no effect. Here also you are giving it. Now maximum is in D. D has maximum electron density. No, not D. E has maximum electron density. Then you have D, because here you have N nitrogen that is giving and 2 methyl. Here you have only 1 methyl and oxygen. Here also it is plus M but only 1 methyl. Then you have A. Then you have B because there is no effect. Then you have C because it is withdrawing the electrons. So answer is, right answer is EDABC. EDABC. So answer is D is the correct answer here. Right? Okay, everybody. So answer is D is the correct answer here. Now let's see the test of amines and anilines. Okay, these 6 tests we are going to do, and this is the last part of amines. After that, we'll see purification. Right, everybody? What is happening there in the chat box? I'm curious to know what you guys are talking about. So now see, if you talk about this test of amines and anilines, let's talk about this. When I say which of the following tests is most frequently repeated is Hinsberg, then carbylamine. Now, these are the most repeated tests that they ask you. Azotite test is also like asked, but HNO2 and Hoffmann mustard oil, this I would say Hoffmann mustard oil has least chances, but they can ask you. You never know, right? Okay, so let's talk. First is carbylamine reaction. What is carbylamine? That is to test primary amines. Test of only primary amines. Whether it's aromatic or it's aliphatic, it will test. Okay? Now, its mechanism, based on mechanisms also, the questions are asked from carbylamine, right? Aliphatic aromatic primary amines on heating with chloroform, that is CHCl3, and ethanoic potassium hydroxide, you can say KOH, NaOH, whatsoever, they give you isocyanide. That is nothing but it is RNC. That has a very foul smell, right? This RNC has a foul smell. That's how it is predicted that if any organic compound is giving you foul smell, that is of isocyanide, that means it is primary amine. Okay. Secondary and tertiary amine do not show this reaction. This reaction is used for the test of only the primary amines. Now let's talk about this. How it is done. Can you tell me the same reagents we have used somewhere else also? This is going to give you a electrophile, that is dichlorocarbene. Dichlorocarbene. How many of you remember we have done it in aldehydes? We have done it in alcohol phenols. Dichlorocarbene. How dichlorocarbene? Foul smell means bad smell, right? So dichlorocarbene is also formed in Reamer-Temer reaction. Yes, very good, Sabrina. That is Reamer-Temer reaction. Okay, that is going to get formed. Now, this is going to be Reamer-Temer reaction where dichlorocarbene is formed, and it is going to give you isocyanide, that is a foul smell, and that is also called as carbylamine. Let's talk about how this takes place. Now, first thing is always what will happen. Base is going to attack. Now, this is the generation of electrophile, that is dichlorocarbene. This is a step that is only for the generation of dichlorocarbene. Okay? You have chloroform, you have base. Base is going to abstract the proton here. So base is going to attack here. It will abstract the proton, and here this particular bond will shift here. You will have C negative Cl3. Now again Cl negative will be taken out, and you will have the formation of dichlorocarbene that will act as an electrophile. This same step we have done in Reamer-Temer reaction as well, right? But this is a difference that we will see here. That is you have RNH2, right, amine, and this is dichlorocarbene. Now some students feel that, ma'am, this is lone pair, so ma'am, this should be electron deficient. This is also, ma'am, this is electron rich, this is also electron rich. How this is happening? But this is electrophile. If you see, this has how many electrons? 1, 2, 3, 4, 5, 6. It is 6 electron species. Octet is not completed here. So it is electron deficient. It is electron deficient. That is why aniline is attacking on its electron deficient position. This lone pair is going to attack here. These are the lone pairs that are going to attack here. The lone pairs are going to attack here. Right? Once the lone pair attack, you will have Rn. H2 is already there. You have CCl2. Now nitrogen is forming 4 bonds. That is why it is having this positive charge here. Right? You will see the positive charge here of nitrogen. Carbon, ma'am, why it is having negative? Because initially it had 6 electrons. Now it has 8 electrons. That is why it is acquiring this negative charge here. Right? So this is negative. So now what will happen? Again, the base is going to abstract the proton. The base is going to again abstract the proton here. So this H positive will leave, and the electrons will shift to this side, and that will become Rn. Right? This is Rn. When it is shifting here, you can say, wait a minute. So it is shifting here. We need to form 3 bonds here. Not 1 pi bond we will form now. This is Rn, 1 pi bond here. This sigma is shifted to pi. This is 1 Cl will be eliminated here, because now carbon will have 1, 2, 3, and this negative is also there. That is why what will happen? This Cl will be shifted here. So what you will have RNH. So yeah, I don't know if by this it is clear to you or not. I'll just write it myself only when I am finding it difficult to tell you like this. Okay? See what is happening. This attack is going to take place because the way it is looking, actually it's not that tough. This is R, this is N. N has 2 hydrogens here, right? And this is C. This is Cl, this is Cl. Now this N will have this positive, this will have the negative. Now see what will happen. Base is going to attack OH negative, is going to attack here, it is going to abstract the proton. This pi bond will shift here, and hence you will have here N, this is R, this is double bond, this is C, and you know when this is attacking here, 1 2 3 4 5, so it can 4 bonds with negative charge carbon cannot handle, so this also will leave from this side. So here you will have C, only one Cl, this is negative, again this is positive. Okay, again what will happen, again OH negative is going to attack, it is going to take out this will shift here, this will again shift here, and here you will have same thing. Now we are doing twice, right? And again you will have the formation of R N triple bond C. That's why here you will have negative, here you will have positive, right? Okay, that is isocyanide. And it is only shown by primary amines, it is not shown by any other amines, right? Okay. Sujan, I have already taught you that in aldehyde ketone, right? In amines you don't have that. I have already told you, taught you this in the previous marathon, right? Okay, yes. Understood? So next reaction is going to be reaction with Hinsberg reagent, and that is Hinsberg reagent, benzene sulfonyl chloride, that is the Hinsberg reagent, reacts with primary, secondary, and with tertiary does not react. Different manners, let's see how to distinguish. So if you talk about primary amines, there is a lone pair, there is this HCl will be eliminated, and you will have benzene S double bond O, NHC2H5, NHC2H5. Now here, because in the product that is formed, you have hydrogen, that is why it is soluble in the alkali. So with primary, you will have a product that is soluble in the alkali. Secondary, if you see, it is soluble in the alkali. In the secondary, this is 2-degree amine. Again, same thing will take place, HCl will be eliminated. But now in the answer, you don't have no hydrogen attached to nitrogen. So it is alkali insoluble. It is alkali. So 2-degree will also give you product, but it will be alkali insoluble. Right? Okay, 1-degree is going to give you the product that is alkali soluble. 2-degree is going to give you the product that is alkali insoluble. That is alkali insoluble. And what about 3-degree? What about 3-degree? 3-degree is not going to give you any product. I'll just write this here. 3-degree does not give you. If I say this is 3-degree, if let's say here you have C2H5, there is no nitrogen, no hydrogen or nitrogen here, so no product in 3-degree. So tertiary will not give you any product only. Primary will give you alkali soluble, tertiary will not give you, secondary will give you alkali insoluble. Right now, JEE 2025 question is, which among the following reacts with Hinsberg reagent? Tell me, everybody. Okay. Which among the following reacts with Hinsberg reagent? So Sujan, I think you don't know about this YouTube feature. So there is a very unique feature on YouTube. That feature is that you can actually watch the replays and recorded version as well, right? So after the class ends, you will go back to the Gabriel Fethele. I will be as it is, same manner that I taught in the live class. It will be there, right? So you can watch that. It is completely free, okay? So which among the following reacts with Hinsberg reagent? See, primary you need to have, this is primary, this is tertiary, so it's not possible. This is reaction we want to know. This is primary, it will react. This is primary, it will react. This is 3 degree, it will not react. This is 2 degree, it will also react. So A, C and E. A, C and E will react. Answer is A, C, E. So answer is fourth is the correct answer here. Right? Okay. Yes, everybody. Next question is Hoffmann bromamide degradation of benzamide. Right? Wait a minute. Hoffmann bromamide degradation of benzamide gives product A, which upon heating with CHCl3 and NaOH give product B. Acha, they are saying that Hoffmann bromamide degradation of benzamide. Benzamide means this thing we are talking about, CONH2. It gives you a product A. That is simple. It gives you NH2 aniline. And after aniline, you reacted with CHCl3, that is carbon. See, this particular reaction is Hoffmann bromamide degradation. This is carbylamine reaction. So both are important and both of their mechanisms are important, right? So here you will see the answer will be, this is NC is formed, right? Okay. So the structure of A and B are this. A is the correct answer, aniline, then isocyanide is formed here. Right? Okay, everybody. So A is the correct answer there. Next question you have, that is benzene isocyanide. Benzyl isocyanide can be obtained. So benzyl isocyanide means this thing. Benzyl means CH2, isocyanide means here you will have NC. Not cyanide, it's isocyanide. So if you prepare it with AgCN, then this will be converted to CN, not NC. So this will give you this thing, CH2CN, which is not the correct answer. This will give you, if you see, this is carbylamine reaction. Clear it is? This is going to give you CH2NC. So answer is B is the correct answer here. Right? Okay. Here also it is going to give you CN here because it's a very good leaving group. Right? And this does not show carbylamine test because it's secondary amine. So it will not show, only primary amine will show you this test. So answer is B is the correct answer. Okay. Only B, right? Wait a minute. A, where is A? Okay, yes, I too forgot only one thing. In the very, very initial stage, in the very, very initial stage, we learned that if you have K positive CN, KCN, if you have ionic, then it will react with the C. Then carbon will get connected here. But if you have AgCN, very good. If you have AgCN, then this is the covalent bond. That's why I didn't look at only. This is the covalent bond. That's why this Ag will be covalently connected with this carbon. So this carbon is not available. This will connect via this nitrogen. So this is very, very important thing, that this will give you CH2NC because of this covalent bond here. So A and B both are going to give you the correct answer. So answer will be C is the correct answer here, right? Because some small things that we did way back in haloalkanes, halorine, we discussed about that, right? So, acha. Now let's talk about Hoffmann mustard oil test. Wait wait a minute. And I'll just give you directly what to do. Right? This is the thing that you will have. And wait a minute. Acha, this is by mistake I have. Chalo. ठीक है. Wait a minute. See, if you see this here, this is Hoffmann bromamide degradation. Let's talk about degradation. I'm saying Hoffmann mustard oil test. So in this case, you have primary amines in the starting, right? You have primary amines here. So let's talk about that. That is primary amine, right? And this is CS2 in the presence of HgCl2 and you heat it. You will have the preparation of Rn double bond C double bond S, right? So just remember this isothiocyanate, okay, because of this sulfur it is called as isothiocyanate that has mustard smell, mustard oil smell. Mustard oil smell is there. This is isothiocyanate. Okay, that is there. Okay. So just remember this gives this test, and here also only for primary amines. This is not given by any other amine. Primary amine or aniline. Primary aromatic or primary aliphatic. Okay? Only this will give you the test. Right? Primary aromatic, same as carbylamine. In case of carbylamine, you have isocyanide. Here you have isothiocyanide. Okay? Okay? Now let's see reaction with nitrous acid. This is the last distinguished test that we are doing. Nitrous acid, that is HNO2. Let's see. Used to distinguish between primary, secondary and tertiary means this reaction carried out in the situ from mineral acid and sodium nitrate. Primary aliphatic amines react with nitrous acid to form aliphatic. Simple thing is primary, they will give you diazonium salt, right? So the primary, if you see primary aliphatic are going to give you diazonium salt which is unstable. Now Vicha, I told you about aromatic. If you have aniline here, this will form aromatic diazonium salt, which is still stable between 0 to 5, but this is not at all stable. It is not even stable at 0 to 5 degrees Celsius. Like your aromatic diazonium chloride that was stable at 0 to 5. This is not even stable at that. So it is directly going to give you alcohol, right? Okay, so if alcohol is formed, you can say that primary aliphatic amine is present here. Aromatic amines react with natural low temperature, right, to form diazonium salt. But here you need to warm it. Diazonium, a very important class of compounds used in synthesis of variety of ammonium chlorides that we have seen. This is stable at 0 to 5 degrees Celsius. This is stable. If you warm it above 5 degrees, then it will be converted to phenol. Right? Okay. Acha, now let's see. Next thing, let's see some questions that we are left with. Right after that, I think how many questions we are left with? 1 or 2 questions we are left with. After that, we'll start with the purification thing. Sleepy ma'am trying to listen class. Arey, little bit we are left with, okay? Don't worry, the class will be over by like 11 or I think 11:30. Okay? Okay. Right? The major product of the following reaction. What is the major product of the following reaction? NaNO2. Then you have CrO3. Then you have H2SO4. Right. So three reagents you have. First is NaNO2. Let's see what will happen here. Let's talk about that. Okay. So first is you have NaNO2. In case of NaNO2 and then you add H positive here, first thing is bacha, this will be converted to N2Cl. Okay? Then this is converted to OH. Why? Because you add H positive. See, we know that whenever you have, understand, not add H positive, understand, I told you that if you have aliphatic diazonium chloride, this is not aromatic, this is connected to aliphatic carbon, then that will directly be converted to OH. So that's why you have here OH. Okay, this is converted to N2Cl, then to OH. Understood? So here you have OH. Rest of it will not change, it will remain as it is the same. Second is CrO3, which is a very good strong oxidizing agent. This is Jones reagent, strong oxidizing agent. Now strong oxidizing agents, they convert, you have OH here, you have OC double bond OCH. So OH is converted to COH. So here you have COH, this is converted to COOH. So this part is converted to acid here, right? This part is converted to acid, that means OH is being, now this we learned in aldehyde ketone as well, we learned it in phenol, alcohol phenol as well, right? Then the third reagent was this concentrated H2SO4, that is a dehydrating reagent. Dehydrating is going to eliminate water. So where all water can be eliminated, if you see, this is COH, here OH, and here hydrogen can be eliminated, and here intramolecular dehydration will take place, right? Because this is also quite acidic in nature, so intramolecular, and it will form a six membered name. Let's see, this is 1 2 3, this is 4, and this is 5, a 5 membered, no, this is how, this is 5, this is hydrogen only, na, this is 5. So 5 membered ring is formed. On the fourth position you have double bond O. So it is 1 2 3. On the fourth position you have C double bond O, right? On the fourth position you have C double bond O. Understood? Now next is, ma'am, this is going to happen here. What about this one? This is ester. If you remember ester, when you add water and H2SO4, that is hydrolysis takes place, right? So ester hydrolysis takes place. This is ester hydrolysis. Do you remember? You just need to learn that what are these reagents, where which reagent will work, right? So this is going to, this bond is going to collapse, and here you will have H and here you will have OH, right? This is what happens. Alcohol and acid is formed, CH3COOH, and here alcohol OH is formed. This is what happens in ester, na? In ester you have R, C double bond O, O R dash. Here what will happen? This bond will break. No, not this bond. This bond will break. You will have H and OH here. Same thing is going to happen here, right? Okay, and that's how you have the formation of benzene. This is OH and this is 5 membered ring with double bond O, and that was a very unique question, right? So answer will be A is the correct answer here, right? Okay, everybody, last step was very unique here. Right, students, now let's see the last part of amines chapter, right? Okay, understood? Acha, if I see if I see azodite test, that is coupling reaction, the azo products obtained have an extended conjugate system having both the aromatic joint through N double bond N bond. The compounds are often colored as dyes. So what you will see, you have phenol, this is this. Always from the para position, it will take out H and it will form benzene N double N2. This is benzene OH, right? So with the phenol, how do you remember? Phenol has O na, so that's why orange color dye is formed here. From the para position, you take out the hydrogen. Okay, so same in case of aniline, you have this thing. It will take out and it will form. It will combine together benzene N2, benzene NH2. Now this is a yellow color dye with aniline. With phenol, it is orange color dye. With aniline, it is yellow color dye. And with beta naphthol, this is also called as beta naphthol. This is also famous and this question is also important. So here again, from where? From this hydrogen, this HCl and this hydrogen will leave, and here you will have benzene N2. It is connected, and here this is a not orange color, you can say this is scarlet red color dye. Okay, scarlet red color dye, scarlet red color dye that is formed here. Understood, everybody? Understood? Yes. Which one do you want me to repeat? Do let me know what you want me to repeat. Acha, now let's see JEE Mains 2019 question, that is a test performed on compound X and their interference. What is that test performed here? Let's talk about that. The test is 2,4-DNP test. It gives you color precipitates, that means there is carbonyl group present there. Okay? Iodoform test, yellow precipitate, it means this carbonyl group is perfectly like this. Okay? Azodye test is not given, that means there is no aniline here. So aniline should not be there. It should not be there because it is giving you no dyes being formed here, right? Okay, so either of these two, but it has CHO. This will not give you iodoform, this will give you iodoform. So answer is B is the correct answer. Okay, yes, everybody understood? Yes, got it? And that's it. Now I'll just take out your purification. Tell me everybody. So little bit more time I'll take, and after that I'll take your leave, right? Don't worry, I'm gonna take only 40 minutes more, right? Okay, because the next thing that we are going to do is quite simple, quite easy, and I don't want that in the exam you do tough things but easy things you don't do and we end up having that regret. That's why purification of organic compound I have divided into two parts. Today we'll do only purification like sublimation, crystallization, all these things. And in the next class, because biomolecule is also, it will take 3.5 hours to complete biomolecules, and 1 hour I'll take for qualitative quantitative analysis. Okay, last year they have asked question in 2025. Earlier it used to be a very chapter that students used to skip, very low priority chapter, but last year questions were seen from Lysagna's test, that is in qualitative quantitative analysis. Questions were seen from this full qualitative quantitative part. Till now I'll be very blunt with you. Last year, as of I remember, questions were not asked from purification, but last year, even qualitative quantitative analysis, they didn't ask you any question, right? So that's why, no doubt, qualitative quantitative analysis is on a much higher as compared to purification, but purification is a very simple thing, so I would not advise you to skip it. Go through, give it just these 30-40 minutes, and you don't even have to revise it. It's very simple. Okay, right? Okay, everybody. Do you want a small break? Okay, I'll give you the break. Don't worry. Tell me how much time you want. Oh, 10:20, no? Okay. So, uh, I have already made like so many videos on that, telling you what is important, right? Mm, yes. Chalo. Now it's a very, very small, hardly few slides you have here. Hardly few slides you have here. So we'll do that. Now tell me if you want break before that, I'll give you break. Right? 5 minutes break. Chalo, theek hai. So I'll give you 5 minutes break, right? Even I take little bit rest. And after those 5 minutes, we are going to complete this purification part. Hardly 30-40 minutes it is going to take us. And you'll be done with this thing. Please, I'm again saying don't take these things as I don't want to do this. It's so simple. This is never they have asked. If you ask, ma'am, is this high priority? No. Purification part is not high priority. Should you skip it? No, because it's so simple that if you skip it, it's not going to take much of time. So rest is your choice how you want to do. Right? Okay? Yes. But 5 minutes I'll give, okay? So some of you are asking for break, so I'll just give you 5 minutes break. Okay? Break just for 5 minutes. So I'll see you all in 5 minutes, and that is 9 9:30. I'm saying 10:30 p.m. 10:30 p.m. Hello, yes, everybody. Do let me know if I am audible to all of you or not. Yes, students, everyone in the chat box, do let me know I am here only. Yes, yes, I am here only. I am here only. Yes, students. So, purification of compounds, right? Let's talk about very simple, very easy. This is very easy. Thank you so much. Thank you, guys. Thank you so much. Now let's finish this, okay? Let's do this 30-40 minutes it will take, right? So, purification of organic compounds. First thing is, once an organic compound is extracted, even if it is by natural source or synthesized in the lab, it is essential to purify it because you will see in organic compounds there are so many byproducts also that are formed, so we need to separate them, right? So various method can be. Purification of organic compounds are based on nature of the compound that is present. So based on the nature of the compound, firstly we'll talk about two things, that is sublimation and crystallization. There are other things as well, right? Sublimation, crystallization, chromatography, then there is distillation, then there is differential extraction. These are the 4-5 methods that we'll talk about, right? So firstly I'll be talking about solids. When you want to have like solids, that means I can categorize firstly purification in terms of solids, right? If one of them is solid or one of them is forming the solid. So there are two parts. First is sublimation, other is crystallization. Sublimation is when solids are directly converted to vapor. So let's say you have two compounds where one is sublimable, other is not sublimable. That means one is directly converted from solid to vapor, other is not directly converted from solid to vapor. So you can say solid is converted directly into vapor without undergoing any liquid phase. Without undergoing any liquid phase, it is directly converted to liquid. It is directly converted to gas. Purification of iodine, camphor, that we say camphor is kapoor that is in our house, right? Naphthalene balls that we use in our house, ammonium chloride, iodine, all these are the sublimable substances. Some solid substances change from solid to vapor directly. They don't undergo any liquid state, that is sublimation. This method is used to separate sublimable compounds from non-sublimable compounds. Like for example, you have, wait a minute, if you are able to see this or not, right? For example, you have a mixture of compound where there is some amount of ammonium chloride and rest of it is some other compound. So ammonium chloride vapors will be there over here, and that's how sublimable compound is separated from non-sublimable compound. Funny part is sublimation, I can guarantee that they will not ask. If they ask you, it's free number that they are giving you, because there is nothing to teach you here. Sublimation, you studied in lower classes, right? You have one sublimable, other is not sublimable. One will be directly converted to vapor, other will not be. That's how you separate them. Next is crystallization. It is based on difference in the solubilities. So what is the difference you have here? Difference in the solubilities of the compound and the impurities in the soluble solvent. So what exactly we have here, right? You have like crystallization is basically what we do here. We have an organic compound, through certain process we form the crystals. Now tell me which one will form crystal, more soluble or less soluble? The one that is more soluble will not form any crystal, but the one that is less soluble, it will form crystals. So sublimation is based on the difference that one is sublimable, other is not sublimable. Crystallization is based on the fact that one is has less solubility in that certain solvent and other has more solubility. The one which is easily soluble, dissolvable, that will not form crystals. The one that is less soluble, that is going to form the crystals, right? Okay. Processes: impure compound dissolved in the solvent at high temperature. Solution is concentrated to get nearly saturated. Saturated solution means where no more solute can be added. On cooling, what you will have, the compound that is less soluble, it will form the crystals, and then you filtrate it and you will remove the crystals and the compound is removed. The compound is separated. The filtrate contains impurities. Filtrate, see, whenever we filter something, right, the thing that you have here is the filtrate and this is the residue that you have. Okay, so they were saying filtrate contains impurities. Impurities impart color in solution, are removed by activated charcoal. So when you separate, crystals are separated out and you're left with filtrate. That filtrate has all the impurities and that is why it will impart color to them, and you can separate the impurities by adding the activated charcoal, right? Okay, next is based on the solubility and impurities in solvent. Impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at high temperature. If the compound is highly soluble in one compound and very less soluble in another compound, crystallization can be satisfactorily carried out in a mixture of these solvents, right? Purification of sugar and purification of potash alum are done as this one, because if you have two solvents, one is easily, that is, you can say easily soluble, other is not soluble. In other solvent, this compound is not soluble. Mix them, because we need to form crystals. Crystal is inversely proportional to solubility. So if crystals are getting formed, that means the solubility is less there. Okay. Then other three methods are distillation, differential extraction, and chromatography. Other three methods are distillation, differential extraction, and out of this now you will find chromatography. According to me, the question they can ask you either from distillation or chromatography, and I like from sublimation and crystallization, I don't think so they will ask you. Still, I told you because it's just a definition that you need to understand that okay, sublimation is based on sublimable and crystallization is based on solubility, right? Now we will discuss distillation, chromatography, and differential extraction, right? If you talk about distillation, this is actually based on the difference in the boiling point, right? So you have compounds based on distillation means what we are saying that you heat it. Let's say you have A plus B compound. Let's say this has boiling point TA, this has boiling point TB. Let's say boiling point of TA is greater as compared to B. The one which has more boiling point, it will form vapors very with a difficulty. The one which has less boiling point, it can easily form vapors. Because what is boiling point? Boiling point is, this is atmospheric pressure when your vapor pressure is equal to atmospheric pressure. If the temperature is less, that means it can easily form vapors, right? So that means A will form vapors easily, sorry, the one which has less now, B will easily form vapors as compared to A. So what you will do, you will put them in a, wait a minute, let me just show you where you will put them. So I'll just show you firstly. You will put them in a round bottom flask, A and B, both of them. One will be easily vaporizable. The one that has less boiling point will be easily vaporizable. The one that is fast in making vapors will be condensed here and will be collected here. The one that is slow in making vapors, the one that has very high boiling point, is very slow in making vapors, will not be condensed here before the one that has low boiling point. So let me just tell you. So we can see this, that this is based on the difference in the boiling point. Distillation is a process which is of separating the component substances from liquid by using selective boiling and condensation will do. Right? Selective boiling and condensation. So let's talk about what is this selective boiling. Selective boiling means appreciable difference in the boiling point should be there. So we'll do that. Four kind of distillation you have: simple, fractional, distillation under reduced pressure, steam distillation. We'll talk about all of them. First is distillation. The principle is difference in the boiling point. Principle is, they can ask you what is the principle on which distillation is based. It is based on the principle of difference in the boiling points of the components that you are separating, right? Also, separate volatile liquids from non-volatile. If I say both are volatile, then the boiling point of, if A is greater than B, then we can say B will form vapors faster. This is the principle, right? Then if I say one is volatile, or you can say A is volatile, B is non-volatile. Now there is no competition, only one will form the vapor. So only this will form vapor, this will not form the vapor only. So this will undergo condensation. Okay? And in this case, which one will undergo condensation? B will undergo condensation. Here, B will undergo condensation because B has less boiling point. So if you have comparison of boiling point, then the one that has less will undergo condensation. And if you talk about volatile, non-volatile, only vapors that is having vapors, only that will undergo condensation, right? Now, types of distillation, we'll talk about the first type, that is simple distillation. Simple distillation is simple. Simple means simple, just difference in the boiling point is there. If you have two compounds which has difference in the boiling point which is greater than let's say 10 degrees Celsius, right, then we can say this simple distillation can be applied here. Volatile liquid from non-volatile, or when they have sufficient difference in the boiling point. There is no complexity here. For example, chloroform and aniline have sufficient difference in the boiling point. They can easily be separated. Liquids having different boiling point vaporize at different temperature. Right? And then we can say vapors are cooled and then they are collected separately. So you have this particular thing. Right? Now guys, see this thing. What you have here. Minimum difference, you can say 20, minimum difference should be that much that when it is increasing, when the vapors of first is getting formed, the second vapor should not be there. You can say, I think like 20-30 degrees Celsius is good enough difference, right? Okay, it is good enough difference. So if you see this here, so it's a very good difference. So it can easily be separated by, here the difference is around I think 50-60 degrees Celsius now. So they can easily be separated by this simple distillation, right? So here what will happen? The one which has less, so this is for chloroform and this is for aniline. Which has less boiling point? Chloroform has less boiling point. So in this case, they can ask you a question like this, that this is the boiling point, which one will be crystallized? The one that has less boiling point. So you can say chloroform is crystallized. So I'll now just tell you that what exactly, not crystallized, it is condensed. I'm saying crystallization, there also I have written crystallization, no. Okay, condensation, it is condensed. So now see one thing, you have two things, that is A and B. This is A, wait a minute, this is A and this is B, right? This is A and this is B. Now what you have here, this is A, this is B. I have written C and A here, so I'll write C and A only. This is C, this is A. So what will happen, chloroform can easily form vapors because it has less boiling point. So you will have the vapors of chloroform here that will go further here, here, here. It will get under the condenser, they will condense, and here you will have the liquid of chloroform, right? After all of this is done, right? Because the difference is very high. Once you have reached 340 Kelvin, 350 Kelvin, 360 Kelvin, all of these vapors are condensed. Then you will reach, after some time, you will reach the boiling point of aniline. Then aniline you can take out separately. So it is very easy to separate from this distillation if you have simple distillation, if you have very good amount of difference here, right? Around bottom flask on boiling vapors of lower boiling point. Now this is very important line that I have been telling you third, fourth time. Vapors are condensed by using condenser and liquid is collected in a receiver. Vapors of higher boiling point form later. Higher boiling point, later it will be formed, right? Second is fractional distillation. Now what are speed breakers for, right? Speed breakers are for which thing? So that you can, so that your speed can decrease, right? When you're moving so fast, why the government has speed breakers on the road? So that your speed can be lowered, right? Same thing, vapors are moving fast, fast, fast. Both the compounds, they don't have as such difference in the boiling point. So what will happen, this method is used when the difference in the boiling point of two liquid is not much. Vapors of the liquid with higher boiling point condense first, condense before the lower boiling point. Isn't it weird? Isn't it different? What is different? We said that here vapors of lower boiling point are formed first. Here we are saying high boiling point condense before the vapors of liquid of lower boiling point. That means the principle is opposite here. So what will happen here? Whenever someone is at a very higher speed, what will happen? Speed breakers will be there, police can be there, right? Police will stop them. If someone is like driving really fast, police caught them. So what police will do? Police will be like, now your speed is 0, right? So with higher speed, it is condensing faster. Ma'am, what exactly is the speed breaker? Let's talk about this. These are the speed breakers that you have. Glass beads. Let me see if any zoomed in version of that. This is in your NCERT that is given. Either you can have glass beads like this as a speed breaker, or this kind of bubble plate can be there, right? Bubble plate can be there. Okay, so I'll just write it. It is actually like this. Okay, this kind of bubble plate can be there. So two things are there, bubble plate or glass beads. So what will happen in this technique? Vapors of liquid mixture are passed through fractionating column. Fractionating column means the one that has speed breaker. In your layman language, you can say speed breakers, with the speed breakers, right? Before condensation, fractionating column are available in various sizes and designs. A vapor rising up in the fractionating column become richer in more volatile component, right? The vapor that is rising above, that will become rich in more volatile component will be there. So what will happen exactly here, right? This we have done for liquids having less boiling point, less than 20 degree Celsius. If the difference is less than 20 degrees Celsius, then you will use this. So what will happen, just remember, in this case, the one that has higher boiling point, if I say two liquids A and B are there, so A will vaporize, A will condense faster. Okay, A will condense faster. It is exactly opposite to simple distillation, right? Okay, a fractionating column provides many surfaces. Now what exactly fractionating column is doing? It is providing many surfaces for heat exchange between the ascending vapors and the descending condensed liquid. So what is happening? The one who was faster, who was like, there are some people now who are like, hey bro, I am so fast, I'll go super overconfidence. They are those kind of vapors. So A is a super confident vapor, right? A is a super confident person. He's like, bro, I'll go and no, I'll boil at lower temperature, this and that. But what exactly will happen? Once B starts vaporizing, it will condense back, because of these glass beads. And by the time A is coming back, B is coming back, A starts to form vapors, right? And that is why A will condense at a faster rate as compared to B, right? Because of this phenomena that is called as heat exchange between ascending vapors and descending condensed liquid, a low boiling point is collected in the receiver. So in the receiver, you have liquid in the distillation flask enriched in high. Wait a minute. The remaining liquid in the distillation flask gets enriched in high boiling point. Yes. So what exactly is happening here? What we are saying, wait a minute. Vapors of lower boiling component are formed first. No, not here. Higher boiling point condense before the vapors of lower boiling point. Higher boiling point will condense before, because of the glass beads that will start condensing. And that is why, because higher boiling point is being condensed here, right? That is the reason what will happen. Higher boiling point is condensing here. And because of that, what will happen? Where is that point? A low boiling point liquid is collected in the receiver, because high boiling point is getting condensed by these glass beads, right? And lower boiling point is received in the receiver. Okay, so remaining liquid in the distillation flask gets enriched in the higher boiling point. Remaining liquid that you have in the flask, that round bottom flask, that will be the higher boiling point. Okay, each successive condensation and vaporization unit in fractionating column. Fractionating column is the one that has glass beads. These are the glass beads. So when the vapor is vaporizing, it is getting condensed. Vaporizing, getting condensed. Vaporizing, getting condensed. Why? Because of these heat surfaces, heat exchange between ascending and descending condensed liquid. It is getting this. So each successive condensation and vaporization is called as theoretical plate. Okay, these are just the definitions, right? What is happening, guys? Again, I am telling you that, see what is going to happen here. Liquid A and liquid B are there. B will evaporize, and it will go here. A will also try to do that. A will be like, bro, I am also there. So I'll just show you the story that is there. B we are saying is at lower, so lower one will go. This I am denoting by blue, and this one I am denoting by red. So what is happening here? This will condense, but because the difference is very less, so the other liquid will also start vaporizing, but it will start condensing, vaporizing, condensing, right? So what will happen? One of the liquid is condensed at a higher rate, and that liquid is of higher boiling point, and that condensation is happening. it is not letting this A go beyond this. And that is why in this you have lower boiling point, and here you have this one is higher boiling point, that is getting condensed again and again. Understand everybody what we are doing here? Right? Okay. Yes. Acha, that's it. Now that is there. Separate differential fraction of crude oil in petroleum industry, that is done. Right? So that has the application. Vacuum distillation. Vacuum distillation is, this method is used to purify liquids having very high boiling point and those which decompose or at or below their boiling points, which has very high boiling points, very high boiling points. So what you will do? Tell me what is boiling point. This is a very simple way I'll teach you. Tell me what is a boiling point. Boiling point is when vapor pressure equals to atmospheric pressure. That means I can say one thing. If this is the atmospheric pressure, this is a vapor pressure that you have, right? This is the atmospheric pressure, this is the vapor pressure that you have, right? And the difference is the boiling point, right? Isn't it? And the difference will be the boiling point. So I'll just write it here. This is the atmospheric pressure, right? This is the atmospheric pressure and this is the vapor pressure. And the difference that you have here, is the boiling point, right? The difference that you have here is the boiling point. Can you change the vapor pressure of the liquid, the vapor pressure of the liquid at that point? You can't. Can you change the atmospheric pressure? No, ma'am. But what we can do is, we will apply vacuum here so that we can change the atmospheric pressure, because this is a very high boiling point. I want to decrease the boiling point. Two things I can do. Either I change the vapor pressure, then only it can be decreased, or I change the atmospheric pressure. So here what we are doing, we are changing the atmospheric pressure. How we are changing the atmospheric pressure? By making the atmosphere as a vacuum, right? So what we are doing here, see this. Liquids are made to boil at a temperature lower than their normal boiling point. We forcefully make them boil at a lower boiling point. We change the atmospheric pressure to vacuum, right? The pressure of atmosphere is reduced with the help of water pump or the vacuum pump. So we reduce it with the help of vacuum or the water pump. So what we have here, distillation under reduced pressure, because we reduce the atmospheric pressure, right? Reduce the atmospheric pressure. This method is used to purify liquid having very high difference in the very high boiling point, so that they decompose at a lower boiling point. Glycerol can be separated from spent IE in soap industry by using this technique. These examples are very important. They are written exactly in your NCERT, right? So if you see this here, what is happening? You have liquid A and B, right? But they have very high boiling point. So what you will do? This is the atmosphere. This is the atmosphere. This is the atmosphere. So you want to change the atmosphere only. You want to change the atmosphere to vacuum. So you will have a vacuum pump so that it can decrease the pressure. Once the pressure here, everywhere is decreased, because the atmospheric pressure is lowered, now the boiling point is lowered. Got it? Yes. Yes, don't worry, I had my dinner, right? Tell me, do you understand this part? that what we are doing here, we are lowering this part, we are lowering this part, we are creating the vacuum and we want to lower this part here. We are not changing the vapor pressure of the liquid, we are changing the atmospheric pressure only, and that's how it is now boiled at a normal temperature, at a lower boiling point. That's how it is separated. Is that clear? Okay. Next is you have steam distillation. Let's see how many likes you have given. And I think by now it should be 150 plus, but I think you will. That's such a disappointment, guys. Such a big disappointment. Very big disappointment. So let's talk about steam distillation. In this case, the method is used to substances separate substances which have what thing? Separate substances which are steam volatile. Steam volatile, they are like volatile in steam only and are immiscible with water. I'll tell you that what exactly is there. Steam from steam generator is passed through the heated flask. So now what we are doing, same thing. I'll just देखो बेटा, what is boiling point? This is atmospheric pressure. This is the vapor pressure of the liquid. Earlier we changed in a simple way, you can understand it like this. This is atmospheric pressure. This is vapor pressure of liquid. Earlier you changed this part. You changed atmospheric pressure to vacuum. But now what we are going to do, this is a very simple way of understanding this thing, that now we are going to change this vapor pressure to high vapor pressure. We are going to add the vapor pressure here. Which vapor pressure you will add? Vapor pressure from the water, vapor pressure from the steam you are going to add. Okay. So steam from the steam generator is passed through the heating flask containing the liquid. Mixture of steam and volatile organic compound is condensed. Can you see what is happening here? Mixture of steam and organic compound is condensed. Let's see how. And this is only for those compounds which are steam volatile, which can get mixed with the steam, right? So let's see. To separate substances which are steam volatile and immiscible, let's talk about this. Here what we have, let's say you have A and B, right? Let's say A is steam volatile. So A will go here, 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 here. A will go here. And here you have A, the pressure of A, right? But you know what you're adding here? Wait a minute. Condensed water, vapors, wait a minute. No, my bad. This is the just water, yeah. This is the just water. Wait a minute. This is A and B. And you can say A is steam volatile. A is steam volatile. Steam volatile. Okay? Now what is happening? Here you have water. These, I'll draw this by blue pen. Very sky blue. These are the vapors of water. Vapors of water, vapors of water, vapors of water. Now in this atmosphere you have vapors of water. And because A is steam volatile, so in this what you will have pressure of A, you will have pressure of water. That will be equal to pressure of A and pressure of water should be equal to atmospheric pressure. That's how I said that I increase this. That's how I said that I'm going to increase this part. Right? Okay, that's how I said I'm going to increase this part. Is that clear, everybody? Do let me know in the chat box if that is clear. Right? What we are doing here, the liquids boil when the sum of vapor pressure due to organic liquid P1 and due to water, that is P2, becomes equal to atmospheric, that is P. I have written in a simple way that let's say PA is organic liquid plus P water, pressure of water vapor is equals to P of atmospheric. Now we are changing the other part, right? Okay. So that's it. The organic liquid vapor is at a lower temperature now because see, in vacuum, and this again last part I am saying here, in vacuum you decreased this part. Oi hoy. You decreased this part here. So I'm not able to do that. You decrease this, but here you decrease this. Okay? You increase that. The difference you need to make minimum. Right? Okay, now let's talk about differential extraction. What is differential extraction, everyone? Let us see. PDF will be provided to you, don't worry. See, simple thing is this is atmospheric, this is vapor pressure. You want to decrease the boiling point, either you decrease the vapor pressure of atmosphere that we have done in vacuum by creating vacuum, or you increase the vapor pressure of boiling of this liquid that we have done by adding water vapors. Okay? Okay? Chalo. Now differential extraction. What is differential extraction? That is, this method is used when an organic compound is present in the aqueous medium. Very simple. This is organic compound is separated by shaking with organic or differences. That's one thing. In steam distillation, we talked about that this should be immiscible. Why it should be immiscible? Because here you will have, because in this you will have water also and organic compound also. So if organic compound is miscible with water, then here you won't be able to take organic compound, you won't be able to differentiate organic compound and water. That's why this steam volatile, this is only applicable for those compounds which are steam volatile and are immiscible in water. Right? Okay. Acha, differential extraction is, it's simple. I'll tell you a simple way of learning this. This is, let's say, this is Reena. Okay? This is Meena. And this is Chintu. Pehle Reena is a friend of Chintu. Now, after this extraction, Chintu will go to Meena and Reena will be alone. That is the thing. Yes, that is differential extraction. You got it right. That is simple concept of differential extraction. Let me tell you how. Let me tell you how. So what you have, let me just show you that. This is thing. You have organic compound in the aqueous layer, right? It is firstly organic compound is like, hi water, I'm so happy with you. Now this is the solvent layer. Solvent layer is like, oh, water is so boring. Solvent layer is so interesting. So now this compound is mixed in solvent layer and now water is alone, right? Reena, Meena, Teena. Got it? Okay? That's it. That's it. This is differential extraction. Just remember, solvent should have more soluble. That means this organic compound should be more soluble in solvent. Only then it will go towards solvent and now water will be left alone. Right? That's it. This method is used when organic compound is present in aqueous medium, is separated by shaking with a solvent in which it is more soluble. So organic compound has to be more soluble. Organic solvent has to be more soluble. That means organic compound has to be more soluble in solvent as compared to water, right? So that is there in separating funnel, which helps to separate this based on the difference in solubility of organic compound in different solvents. When organic compound is present in aqueous medium, same thing. Organic solvent and this should be immiscible. First thing, they should not be miscible. This is also a very important point, that organic solvent and the aqueous, that means water, should be immiscible with each other so that they can form two distinct layers should be formed. Organic solvent later removed by distillation or by evaporation. Okay? Once you have this organic compound plus solvent, then you can separate this by distillation process, by evaporation process, you can separate this. Right? Okay? Battery low, oh, koi baat nahi. Little bit we are left with just last part, that is chromatography. Last part is chromatography. Now tell me, what do you mean by chroma? What do you mean by chroma? Yes, everybody. Huh. Last thing that we have is chromatography. Let's talk about chromatography. What we have here, no, I have not acted in any movie, right? This is the movie that I'm acting in, but I'm not acting here, right? So this is the only screen that you must have seen me, right? Chromatography means chroma means color, right? So if you remember, we used to do this in the practical, in your labs and all. You must have done. Your teacher has given you ink to separate the different colors of the ink, right? So that we are going to do, right? But there are so many three different types of chromatography that we'll talk about. Chromatography is occurred. This means that the first used for separation of colored substances found in plants, but now it is used for colorless as well. This is important technique to separate mixtures into their components, purify compounds, and also test the purity of the compound. How we do it? Latest technique, chromatography, is used to purify the compound, test the purity of the compound, separate the compound from the mixture, right? And it is based on adsorption phenomena, right? How adsorption work, it is based on the phenomena of adsorption. So firstly, let's talk about two things, two phases that it is divided into. One is stationary phase, other is mobile phase. So firstly, now you just listen what I am saying, now then I'll connect all the dots, all the things that you have in your mind. Stationary phase, it is stationary, maybe solid or liquid. The mixture of substances is applied onto the stationary phase. Mobile phase, that is also called as eluent, right? Or mobile phase, that is a moving phase. Pure solvent and a mixture of solvents or a gas is allowed to move slowly over the stationary phase. Now I think this all have gotten out of your head, so I'll be telling you with the help of experiments. Okay, what is stationary phase and what is mobile phase? Let's see. Let's discuss chromatography. There we will discuss about these two phases, adsorption, and the second is partition. Adsorption is divided into two parts, column chromatography or thin layer chromatography. Partition is paper chromatography. So firstly, let's talk about column chromatography, right? So in case of adsorption, that is, this method is based on the fact that different compounds are adsorbed at different rates. Different compounds are absorbed on adsorbent to different degrees. Okay, you know what is adsorbent? Adsorbent is stationary phase only. Okay, so common used adsorbents are silica and alumina that we will use, and this is stationary phase. This is stationary phase. It is static, and here the organic compound will be adsorbed. A mobile phase, that is allowed to move over the stationary phase, that will move over the adsorbent. The components of mixture move by varying distances over the station. We'll see that how the one that is I'll tell you that how different components, because of their different adsorption rate, will have different distances. Okay, let's talk about that. See, first, adsorption is based on the fact that different compounds are adsorbed on it. This is commonly used adsorbent are. Okay. Mobile phase can be liquid or gas, two types of things, column and thin layer chromatography. Let's talk about that. First thing is column chromatography. In column chromatography, it involves separation of mixin over a column of adsorbent packed in a glass tube. So in this case, I'll talk about a glass tube. You have a glass tube, column with stop clock, at the lower end. The mixture placed on the top of the adsorbent column is packed in glass tube. So what you will have, eluent means you will have mobile phase, which is a liquid or a mixture of liquid is allowed to flow down the column. ऐसे तो बेटा with this, तो wait a minute, let me just show you what is happening here. ठीक है, मैं ऐसे तो with theory only I won't be able to explain. Firstly I'll show you that what is happening, then we'll go back to the theory. See, this is the adsorbent that you will have, that is the stationary phase. This is in a glass tube. What happens, right? This is a mixture of compounds and this is the solvent, right? And that's how they are separated. After some time you will see all the components are separated here, right? All the components are separated. Now let's see what they are telling you. Now let's see what they are telling you here. This one though you can delete because that was the same thing only that we have discussed before also, right? It involves separation of mixture over a column of adsorbent packed in a glass tube. Adsorbent, that is a stationary phase, that is the lower one. Column with stopcock at the end. Stopcock is this thing. See, this is the stopcock. Okay, so that no more extra stationary phase that goes out of this. We want to stop it. That's why, right? This is, we can loosen it or tight it. Then you have the mixture placed on the top of the adsorbent packed in the glass tube. Mixture is, after adsorbent you have mixture of organic compound. Then eluent, that is the mobile phase, which is liquid or a mixture of liquids, is allowed to flow down the column. Now this is the mobile phase that will flow down the column to separate these things. Stationary phase will remain as it is here because of the solvent that is over here, right? Now solvent is in the upper top layer, is allowed to flow down the column. The most readily adsorbed substance are retained near the top and others come down. The one that is readily adsorbed substance, that means if I see this over here, E is maximum adsorbed, then you have B, then you have C. This is the first question that they can ask you, that out of these three, just remember always the one which is near to solvent will always be adsorbed faster, any chromatography you take. Okay? Okay? This is the last part of the session. Okay? This is the last, chromatography is the last topic that you have. So E, B and C, the one that is on the top is highly adsorbed. Okay? Remember that. Then what you have, most readily adsorbed substance is retained near the top and other comes down with various distances. Involves separation of mixture over column of adsorbent stationary packed in the glass tube. Component of mixture which is more soluble in stationary phase is adsorbed first, then the component which is less soluble in stationary phase. Most readily absorbed substance are retained near the top and other comes down to various distances in the column, right? Okay? Yes, everybody understood? Acha, now thin layer chromatography here, instead of taking this glass tube, you have a glass plate here. Okay? You have a glass plate like this. There you have a dot. So separation of substances, mixture over a thin layer of an adsorbent coated on the glass plate. So it's like you have a glass plate. Wait a minute, let me see if we have any. Okay? So you have this glass plate. You have this glass plate. Okay. You have this glass plate. Yes, I am little. Okay? You have this glass plate and over here you put a dot, right? Same thing, but on this glass plate you have pasted the stationary phase. Phase is same, silica and albinia gel, that is same. But you paste it. In glass tube, you have stationary, then mixture, then you have solvent, that is mobile phase. Here you have glass plate, there you paste the stationary phase, and on that you put a point dot of, after above 2 centimeter, you put a dot of the organic compound, the mixture that you have. A thin layer about 0.2 millimeter thick of adsorbent is spread over the glass tube. Stationary phase is spread. Solution of the mixture to be separated is applied as a small spot at 2 centimeter above. You will have a small spot of it. Glass tube is then placed in a closed jar containing the eluent. Now what will happen? You will have an eluent, right? That is this. This is the eluent which will have, which is exactly the solvent, and this is the glass plate dot, and this is the glass plate which has stationary phase uh, pasted on it. That's how after some time you will see the separation is there, right? But once you see the separation, if you see A, B and C, right, the one that is near to the solvent has maximum adsorption. Just remember this thing. Okay, now you can go through this. Okay, eluent rises up. The components of mixture move up along the eluent to the different distances depending on degree of adsorption. Relative adsorption of each component is expressed in terms of retardation factor, and this is also an important thing, right? Retardation factor is a simple thing here. Retardation factor, I'll tell you what exactly this means. Retardation factor has a very simple formula, that is distance moved by substance from the baseline, that is above 2 centimeter, distance moved by the solvent from the baseline, right? So let's say you have this thing. This is the, let's say this is the solvent. Solvent has moved up to Y. So retardation factor will be, and the component has moved from the baseline up to this X distance. So retardation factor will be X by 5. Okay? That's how, like, rate answer, but they can ask you numerical based question on that as well. Right? Then involve separation of substances over thin layer, component mixture move up along the eluent. This is the same thing, right? Okay, that was your, this is the retardation factor, the formula of retardation factor, right? Okay. Now last is thin layer chromatography. We have done it. You can see it over here. If you have earlier only colored compounds separation was done, but now even colorless compounds can be detected. But for that we have to put it under UV light. Another detection technique is to place the plate in a covered jar containing few crystals of, they can ask you that how to identify colorless substances, by UV light or by iodine, right? Some important reagents used for detection are amino acid may be detected by spraying the plate in ninhydrin solution. This also you must remember the examples, that amino acid, this is also colorless compound, that will be detected by placing it in a ninhydrin solution. This is again from your NCRT. Okay, these examples are from your NCRT, that's why they are important. Achha, last is partition chromatography. Just like you have glass plate, you have a paper, right? Now if I talk about you have a paper, that means just like you will have a simple paper, right? That is partition paper chromatography. Same way you will do this, you will, and just that here stationary phase you will not paste. The paper only has the stationary phase, it is inside the paper only. The paper is a special chromatogram. Okay, this method is based on the continuous differential partition of the components. The paper is a special quality paper known as chromatography paper. Chromatography paper contains water trapped in it, which act as the stationary phase. Already water is trapped in it. You just have to put a dot, put it in the eluent or the solvent or the mobile phase, whatever you call it. The strip of chromatography is spotted at the base with the solution of the mixture is suspended in a suitable solvent. The solvent acts as the mobile phase. Solvent rises up the paper by capillary action. That will rise up. Solvent will rise up. Solvent is the mobile phase. When the solvent is rising up, The paper selectively retain different components according to their partition. In the low phase, in the two phases, paper strip so developed is known as chromatogram, that you have the spots of the separated colored components, just like in glass plate. Similarly, you have here at different heights from the position of the initial spot. Okay, let me see if I can show you that. Just like glass plate, you have this paper, right? And now on the paper you have this, and the components will rise above by the capillary action, right? Okay, based on the continuous differential of the component mixture of this, also known as liquid. So now this is based, this thing you must know that this is based on continuous differential partition of components, right? And this is also called as liquid paper chromatography, right? Stationary phase is water here, mobile phase is also liquid here. Paper is chromatography paper, some important points that I have also ticked before, and it is already trapped. Okay? This is solvent rises up with the paper by capillary action and flows over the spot. The paper selectively retains different components according to their differential. This is very important line, that paper differentiate according to their differentiating partition in two phases, right? You just remember the principle here. Rest of it is same as TLC, that is thin layer chromatography, just like you did it for the glass plate, right? Okay. Now few questions you have. The fragrance of flowers is due to presence of some steam volatile organic compounds, essential oils. They are generally insoluble in water at room temperature but are miscible with water vapor in vapor phase. Okay. A suitable method. So if they are easily miscible with water vapor but not miscible with water, and they're generally insoluble in room temperature, so you can see this is, they're giving a hint of steam distillation here. So answer will be D, that is steam distillation, because here what they are saying that it is miscible with water vapors but not with water. So that means this is a perfect example of steam distillation, right? Okay. My bad. During hearing of a court case, the judge suspected that some changes in the documents have been carried out. He asked for the forensic department to check the ink used to at two different places. According to you, which technique that can give the best thing? So, forensic department to check the ink used. Ink, for ink, the best thing is thin layer chromatography, because it's a dot that you have, right? So for that, thin layer chromatography is used, right? Then the principle involved in paper chromatography is what? In paper chromatography, what is the principle involved? Solubility, volatility, partition, right? Differential partition is the principle involved in paper, because that is based on differential partition, and column and thin layer chromatography is based on this adsorption. Okay. Simple distillation can help in separating a mixture of this and this, which has good amount of difference. Liquids with difference of more than 20 in their boiling points can be separated by simple distillation. So you can say both are the correct things, and second is the correct explanation of it. That is the correct answer here, right? Acha, now I'll do one thing. I'll see if you can answer this or not. Last two, I'm giving you for homework, okay? This question I'm giving you for homework. Let's see if you can answer this. Right, and this one, take the screenshot. This one again, I'm giving you for homework. Let's see if you can answer this. Right? Let's see if you can answer this or not. Right, everybody? Okay. Chalo. No, don't worry. It's not my birthday. Right? It's not my birthday, guys. Relax. It's not, right? There's just spamming it, right? Okay, chalo. Now, guys, I'll see you all in the next class for biomolecules and qualitative quantitative analysis. So, see you all in the next class. Till then, bye bye. Take care. See you all. And don't forget to do your homework. And before going, let me remind you that if you go over here, right? Over here, what you will get is ask Ved any doubt. Click on here and you will get to this. Wait a minute. If I post it here, wait a minute. Let me see if I can. Huh. Okay. So now if you see this on this particular link, you will get the PPT of this PDF of this class. You will also get the doubt. Like if you have any doubt, you can ask your doubts over here. And if you want to do quiz for what we have done today, you can also do it over here, right? So all the things will be provided to you after this. This will be refreshed and it will be provided over here, right? Okay, that is the platform wait for you. And also over here you will see a Clavier Booster series that is right now available at just 999, where 11 part syllabus and 25 full syllabus tests are provided to you, along with 93 high weightage topic tests that is different as compared to this 11 and 25, because these are full mock tests, but those 93 tests are just like you have done one topic, you can give like 15 question test based on that topic, and only high weightage topics are included in that, right? That's a bonus that we are giving you, right? Okay, chalo. Okay then, guys, so that's it for today and I'll see you all in the next class. Till then, bye bye, take care, bye bye everyone.